Jenkins Demystified, Building Robust CI/CD Pipelines. Chapter 1, Introduction to CI/CD, the foundation of modern software development. Before we delve into the intricacies of Jenkins, it's crucial to understand the landscape it operates within. Continuous integration and continuous delivery, often abbreviated as CI/CD. These practices have revolutionized how software is built, tested, and deployed, moving from slow, cumbersome processes to agile, high-speed delivery. This chapter lays the groundwork, explaining the why behind CI/CD, setting the stage for Jenkins' indispensable role. 1.1 The Software Delivery Challenge. Imagine a time, not so long ago, when software development was a much more laborious affair. Teams would work for weeks, sometimes months, in isolation on different parts of a project. Developers would write code, often without integrating their changes with others' work, until a designated integration phase. This phase was often referred to as integration hell, a chaotic period where disparate codebases collided, leading to countless conflicts, bugs, and delays. Identifying the root cause of an error was like finding a needle in a haystack, as so many changes were introduced simultaneously. Testing was typically a separate, manual process performed towards the end of the development cycle. Quality assurance teams would receive a massive chunk of code, often unstable, and begin their arduous process of trying to break it. Bugs found late in the cycle are far more expensive and time-consuming to fix. A small error discovered during integration or testing could ripple through significant portions of the codebase, leading to costly refactoring and missed deadlines. Deployment, too, was a ritualistic event. Releasing new software versions might happen only a few times a year, sometimes even less frequently. Each release was a high-stakes operation, fraught with anxiety, manual checklists, and often late-night troubleshooting sessions. The longer the time between releases, the larger the batch of changes, and consequently, the higher the risk of something going wrong. Customers would wait months for new features or bug fixes, hindering feedback loops and slowing down innovation. This traditional approach was slow, expensive, risky, and stifling to creativity. The market, however, demanded speed, continuous innovation, and high-quality software delivered reliably. This growing need highlighted a fundamental truth: the way software was being delivered needed to change. Enterprises realized they needed to move from a big bang, release approach to a continuous flow of value. This realization paved the way for the adoption of CI/CD. 1.2 What is continuous integration? CI? Continuous integration, CI, is the practice of frequently merging new or changed code into a central version control repository. Instead of isolating work for long periods and merging massive code chunks, developers aim to integrate their code at least daily, if not multiple times a day. The core principles of CI are straightforward yet powerful. Frequent commits. Developers commit their code changes to a shared repository, like Git, often. Automated builds. Every time code is committed, an automated process kicks off a build. This ensures the code compiles and any immediate syntax errors are caught. Automated tests. Following a successful build, automated tests, unit tests, integration tests, etc., are executed. These tests quickly verify that the new changes haven't introduced regressions or broken existing functionality. Immediate feedback. If a build or any test fails, the system immediately notifies the relevant developers. This instant feedback loop allows developers to address issues while the changes are fresh in their minds, making them significantly easier and cheaper to fix. By integrating and testing frequently, teams can detect integration errors and bugs much earlier, often within minutes of their introduction. This eliminates integration hell and keeps the codebase in a healthy, releasable state. The benefits of CI are transformative. Early bug detection. Issues are found and fixed quickly, reducing the debugging effort. Improved code quality. Frequent testing encourages cleaner, more robust code. Reduced integration issues. Small, frequent merges mean fewer conflicts and easier resolution when they do occur. Increased confidence. Developers are more confident in their changes, knowing that automated checks are continuously validating their work. Faster development cycle. Less time spent debugging integration issues means more time spent developing new features. CI is the bedrock upon which all other continuous practices are built. It ensures that the software is always in a known, working state, ready to proceed to the next stages of delivery. 1.3. What is continuous delivery, CD, and continuous deployment? While continuous integration focuses on continuously integrating code and ensuring it compiles and passes basic tests, continuous delivery and continuous deployment take the process a step further, extending the automation all the way to production. Continuous delivery, CD, is the practice where code changes are automatically built, tested, and prepared for release to production. This means that at any point in time, the software is in a releasable state, and a human can choose to deploy it to production with a click of a button or a simple command. The key here is the readiness for release, rather than immediate release. The journey from CI to continuous delivery typically involves CI success. The code base successfully passes all automated builds and unit tests. Automated environment provisioning. Necessary infrastructure and environments, e.g., staging server, are automatically set up. Automated deeper testing. More comprehensive tests are run, such as integration tests, system tests, performance tests, and security scans. Artifact creation. A deployable artifact, e.g., a software package, a Docker image, is created and stored in an artifact repository. Automated deployment to staging pre-production. The artifact is automatically deployed to environments that mimic production. Optional manual approval exploratory testing. A human may perform a final check or sign-off before deploying to production. The benefit of continuous delivery is that it virtually eliminates the stress and risk associated with releasing software. Releases become routine, high-confidence events. Continuous deployment is the natural extension of continuous delivery. With continuous deployment, every change that passes all stages of the pipeline is automatically released to production without human intervention. This means that if a new feature or bug fix is committed, passes all automated tests, and successfully deploys to staging, it will automatically be live for users within minutes. Choosing between continuous delivery and continuous deployment depends on an organization's risk tolerance, regulatory requirements, and the nature of the application. Many organizations opt for continuous delivery initially, then gradually mature to continuous deployment as their confidence in their automated testing and feedback loops grows. The journey from CI to CD to continuous deployment represents a gradual increase in automation and trust in the pipeline. 1.4. The role of automation in CI/CD. At the heart of continuous integration and continuous delivery lies one critical principle: automation. Without automation, CI/CD is merely an aspiration. Why is automation so paramount in this context? Efficiency. Manual tasks are inherently slow and time-consuming. Automating repetitive steps like code compilation, running tests, and deploying applications drastically cuts down the time required for these operations. This allows developers to focus on writing code and innovating, rather than spending hours on deployment routines. Repeatability. Humans, by nature, are prone to error. A manual deployment process might involve a checklist of 50 steps, and even the most diligent person can miss one, leading to inconsistencies or failures. Automated processes execute the exact same steps in the exact same order every single time. This ensures consistency across environments and eliminates "it worked on my machine" scenarios. Reliability. An automated pipeline reliably executes predefined workflows. If a step fails, the system immediately reports it, preventing further progression of a broken build. This increases the overall quality and stability of the software being delivered. Speed. The faster code can go from a developer's machine to production, the quicker new features reach users, and the sooner feedback can be gathered. Automation enables this rapid iteration and response to market demands. Scalability. As projects grow in size and complexity, and as teams expand, manual processes become bottlenecks. Automated pipelines can scale to handle increased workloads without proportional increases in human effort. Transparency. An automated pipeline provides a clear, auditable trail of every change, build, and deployment. This transparency helps in troubleshooting and understanding the history of software releases. In essence, automation transforms a chaotic, error-prone software development process into a streamlined, predictable, and highly efficient assembly line. But how do we achieve this automation? This is where tools like Jenkins come into play. 1.5 Introducing Jenkins, the CI/CD powerhouse. Jenkins is an open-source automation server that has become a cornerstone of CI/CD practices across countless organizations worldwide. At its core, Jenkins acts as an orchestrator, automating the various stages of the software delivery pipeline, from compiling code and running tests to deploying applications to production environments. Think of Jenkins as a central nervous system for your software development lifecycle. It continuously monitors your version control system, like Git, for new code changes. When it detects a change, it automatically triggers a predefined set of actions. It might pull the latest code, compile it, run automated tests, and if all goes well, even push the code to a staging or production server. Why has Jenkins remained such a dominant player in the CI/CD space? Open source and free. Being open source, Jenkins is freely available, fostering a massive and active community that contributes to its development and support. Highly extensible. Jenkins boasts an incredible plugin ecosystem. With thousands of plugins available, it can integrate with virtually any tool in your development stack, from source code management systems, Git, SVN, and build tools, Maven, Gradle, NPM, to testing frameworks, cloud providers AWS, Azure, GCP, and notification platforms, Slack, email. This extensibility is one of its greatest strengths, allowing it to adapt to diverse technological environments and specific needs. Platform agnostic. Jenkins can run on various operating systems, including Windows, Linux, and macOS. It can also manage build agents on different platforms, making it highly flexible. Distributed builds. Jenkins can distribute build workloads across multiple agents or nodes, significantly speeding up the build process and handling large volumes of concurrent jobs. Robust and mature. With over a decade of continuous development, Jenkins is a mature and battle-tested tool, capable of handling complex enterprise-level CI/CD pipelines. In the subsequent chapters, we'll dive deep into how Jenkins accomplishes these feats, starting with setting up your first Jenkins instance and progressively building more sophisticated pipelines. 1.6 The DevOps connection. The move towards CI/CD practices is inextricably linked with the broader philosophy of DevOps. DevOps is a set of practices that combines software development, dev, and IT operations, ops, to shorten the system's development lifecycle and provide continuous delivery of high-quality software. It's not just about tools, it's about culture, collaboration, and automation. CI/CD, greatly enabled by tools like Jenkins, is a fundamental technical pillar of the DevOps movement. Here's how they connect. Automation. CI/CD pipelines automate the build, test, deploy cycle, removing manual bottlenecks and human error, which is a core tenet of DevOps. Collaboration. By providing fast feedback loops and a transparent, shared view of the delivery pipeline, CI/CD fosters collaboration between developers, testers, and operations teams. Everyone shares responsibility for the quality and delivery of the software. Continuous improvement. The data generated by CI/CD pipelines, build times, test failures, deployment successes, provides valuable insights, enabling teams to continuously inspect and adapt their processes for better efficiency and quality. Reduced risk. Frequent, small changes and automated testing reduce the risk associated with each deployment, making releases less stressful and more reliable. This shared responsibility for shipping is a key aspect of DevOps. Consider the journey of a fictional tech startup, Innovate Now. Initially, their small team of developers would manually deploy updates to their customer-facing application. What started as minor inconvenience soon became a major headache. Each deployment took a full day, required extensive coordination, and often resulted in unexpected downtime. As their user base grew, the pressure to deliver new features faster mounted, but their clunky release process became a crippling bottleneck. Frustrated by the slow pace and high risk, Innovate now decided to embrace CI/CD. They implemented Jenkins, automating their build, test, and deployment processes. Now, every code change automatically triggers a comprehensive set of tests. If all tests pass, the updated application is automatically deployed to a staging environment, and then, with a single automated approval, pushed to production. The single-day deployment ordeal shrunk to a mere 15 minutes of automated pipeline execution. This transformation not only accelerated their feature delivery, but also dramatically reduced errors and free up engineers to focus on innovation instead of deployment anxiety. Innovate now had successfully leveraged CI/CD to embody a true DevOps culture, fostering seamless collaboration and continuous value delivery. Summary: in this chapter, we've explored the foundational concepts of continuous integration and continuous delivery, understanding how they address the challenges of traditional software development. We've seen how CI, frequent code merging and automated testing, cleans up the integration process, and how CD, automatically preparing software for release, and continuous deployment, automatically releasing to production, take automation all the way to the end user. We also briefly introduced Jenkins as the powerful open-source automation server that makes these practices attainable for teams worldwide, forming a crucial bridge to the broader DevOps philosophy. With this foundational understanding established, we are now ready to roll up our sleeves and begin our hands-on journey with Jenkins, starting with its history and core principles in the next chapter. Chapter 2: Understanding Jenkins. Its history and core principles. In the previous chapter, we established why continuous integration and continuous delivery are crucial for modern software development. Now, it's time to shine the spotlight on the tool that has empowered countless organizations to achieve these goals: Jenkins. This chapter will delve into what Jenkins is, its fascinating origin story, its fundamental architectural components, and the sheer power of its extensibility. 2.1 Jenkins, the open-source automation server. At its heart, Jenkins is an open-source automation server. This simple definition belies its immense power and flexibility. Its primary purpose is to automate the non-human part of the software development process, with a focus on continuous integration and facilitating continuous delivery. Being open source means its source code is freely available to anyone. This has several profound implications. Free to use, you can download, install, and use Jenkins without any licensing costs. This makes it highly accessible to individuals, startups, and large enterprises alike. Community-driven, thousands of developers, users, and organizations contribute to Jenkins. This vibrant community writes plugins, fixes bugs, adds new features, and provides support through forums, documentation, and meetups. This collective effort ensures Jenkins remains robust, up-to-date, and responsive to the evolving needs of the software world. Transparency and security. The open nature allows anyone to inspect the code, fostering transparency and making it easier for security vulnerabilities to be identified and patched quickly. Flexibility. Users aren't locked into a proprietary system. If a feature is missing or a bug is critical, the community can collectively work on solutions, or individuals can even modify the code to suit their specific needs. Jenkins acts as the central hub that orchestrates the workflow of your CI/CD pipelines. It connects to your version control system, triggers builds, runs tests, generates reports, and deploys applications across various environments. It's often described as the glue that binds together disparate tools and processes in your development ecosystem. 2.2 A brief history of Jenkins. The story of Jenkins is one of innovation, community spirit, and a famous fork. It originates from a project called Hudson, started in 2004 by Kosuke Kawaguchi at Sun Microsystems. Kosuke was frustrated by the manual and repetitive tasks involved in software development, particularly the build and test process. He envisioned a system that could automate these steps, constantly checking for code changes, building the software, and running tests, providing immediate feedback on any issues. This vision materialized as Hudson. Hudson was a game changer. It quickly gained popularity within Sun and then blossomed into a widely adopted open-source project. Its ease of use, extensibility through plugins, and focus on automation resonated deeply with developers struggling with similar challenges. Then came the pivotal event. In 2010, Oracle acquired Sun Microsystems. Following the acquisition, there were disagreements between Oracle and the community regarding the governance and direction of the Hudson project. The concerns primarily revolved around Oracle's increased control and a perceived lack of transparency. In early 2011, a significant portion of the core development team and community members, including Kosuke Kawaguchi, decided to create a fork of the Hudson codebase. They renamed their project Jenkins. A fork in open-source terms means taking a copy of the existing project's code and developing it independently. The decision to fork wasn't taken lightly, but it ultimately proved beneficial for the project's longevity and the community. It reaffirmed the power of open-source governance and the collective decision-making of its contributors. The Jenkins project thrived, quickly outpacing the original Hudson project in feature development, plugin ecosystem, and community adoption. Today, when people refer to the tool, they almost invariably mean Jenkins, a testament to the community's dedication and vision. This history underscores Jenkins' robust open-source foundations and its commitment to community-driven development. 2.3 Key architectural components. To understand how Jenkins operates, it's essential to grasp its fundamental architectural setup, which primarily revolves around a master agent model. The Jenkins master controller. The Jenkins master, also often called the Jenkins controller, is the central controlling unit of your Jenkins environment. Think of it as the brain or the orchestrator of an orchestra. Its responsibilities include scheduling builds, deciding when and where to run your automated jobs or builds, orchestrating pipelines, managing the flow and execution of your complex CI/CD pipelines, ensuring stages run in the correct order. User interface, providing the web-based interface that administrators and users interact with to configure jobs, view build history, and monitor the system. Plugin management, hosting and managing all the plugins that extend Jenkins functionality. Storing configurations, keeping track of job configurations, build results, and system settings. The master itself rarely performs the actual heavy lifting of building software. Instead, it delegates those tasks. The Jenkins agents, nodes. Jenkins agents, also known as nodes or slaves, are machines, physical, virtual, or even containers, that are connected to the Jenkins master and execute the jobs. If the master is the orchestra's conductor, the agents are the musicians. Each type of instrument, programming language, operating system, specific toolchain could be represented by a different agent. Their primary role is to execute jobs. Agents run the build scripts, execute tests, and perform deployment tasks as instructed by the master. Provide diverse environments. You can have multiple agents, each configured with different operating systems, development tools, like specific versions of Java, Node.js, Python, or libraries required for different projects. For example, one agent might be a Linux machine with Maven for Java projects, while another could be a Windows machine with Visual Studio for .NET projects. Distribute workload. By running jobs on separate agents, the master's resources are freed up, and multiple jobs can run concurrently without interfering with each other, speeding up the overall CI/CD process. Communication. Master and agents. The Jenkins master communicates with its agents using a client-server protocol. The master assigns tasks to available agents, and the agents send back their results, logs, and any generated artifacts, like compiled software packages. This distributed architecture allows Jenkins to scale efficiently, handling a large number of concurrent builds and accommodating diverse project requirements. You can start with a single master managing everything, and as your needs grow, you can add more agents to distribute the workload and support more varied build environments. 2.4 The power of plugins. If the master agent architecture is the skeleton of Jenkins, then its plugin ecosystem is the muscle and organs that give it life and remarkable capabilities. Plugins are add-on modules that extend Jenkins' core functionality. allowing it to integrate with virtually any software development tool or service imaginable. This extensibility is one of the primary reasons for Jenkins' enduring popularity. Consider what you might need an automation server to do: source code management, SCM. Connect to Git, SVN, Mercurial, or even older systems to pull your code. Build tools. Invoke compilers, build automation tools like Maven, Gradle, NPM, Ant, MS-Build. Testing frameworks. Run tests written in JUnit, TestNG, NUnit, PyTest, Jest, and collect their results. Code quality and security. Integrate with static code analysis tools like SonarQuebec, security scanners, or dependency vulnerability checkers. Deployment. Connect to SSH for remote execution, deploy to cloud platforms like Oz, Azure, GCP, or orchestrators like Kubernetes. Notifications. Send emails, Slack messages, Microsoft Teams notifications, or update project management tools. Artifact management. Publish build outputs, JARS, WARS, Docker images, to repositories like Nexus or Artifactory. User management. Integrate with corporate identity systems like LDAP, Active Directory, or OAuth providers. For almost every one of these functions, there's likely a Jenkins plugin available. These plugins are developed by the Jenkins community, a vast network of individuals and companies. You can browse and install plugins directly from within the Jenkins user interface, accessing a marketplace with thousands of options. This plugin-based architecture means Jenkins itself remains relatively lightweight and focused on core orchestration. Its true power is unlocked by choosing and combining the specific plugins that cater to your project's unique needs. This modularity ensures Jenkins can adapt to almost any technology stack or workflow, making it incredibly versatile. 2.5 Core Philosophy and Extensibility. The core philosophy of Jenkins revolves around its ability to be a highly adaptable automation engine. It doesn't impose a rigid way of working. Instead, it provides mechanisms to automate whatever workflow you define. This is why it's often referred to as the glue for your CI/CD toolchain. Jenkins fundamentally embraces automation of repetitive tasks, freeing up human effort from mundane, error-prone tasks. Extensibility. Through its vibrant plugin ecosystem, it can connect and interact with virtually any external system or tool. This means you're not forced to adopt a specific vendor's entire toolchain. You can pick and choose the best tools for each job, and Jenkins will likely be able to integrate them. Flexibility. Whether you are building a simple website, a complex microservices architecture, a mobile application, or embedded software, Jenkins can be configured to manage the CI/CD pipeline. It supports various programming languages, build systems, and deployment targets. Auditability and traceability. Every build, every step, and every configuration change can be logged and tracked, providing a clear history of your software delivery process. This philosophy of being an adaptable, open platform distinguishes Jenkins and explains its widespread adoption across diverse industries and company sizes. 2.6 Jenkins and the modern CI/CD landscape. In recent years, the CI/CD landscape has seen the emergence of various new tools, particularly those built natively for cloud environments or integrated directly into source code management, SCM, platforms like GitHub Actions or GitLab CI/CD. So, where does Jenkins stand amidst these evolving tools? While newer tools offer streamlined experiences for specific ecosystems, e.g., GitHub Actions for GitHub users, Jenkins continues to hold a significant and often unique position due to its strengths. Unparalleled extensibility. No other tool boasts a plugin ecosystem as vast and comprehensive as Jenkins. This makes it ideal for organizations with diverse, legacy, or highly customized technology stacks that require bespoke integrations. If you have unique on-premise systems, specialized testing frameworks, or niche deployment targets, Jenkins likely has a plugin or can be extended to work with it. On-premise control data sovereignty. Many large enterprises, government agencies, or industries with strict regulatory compliance requirements prefer to host their CI/CD infrastructure on-premise or within their own private cloud. Jenkins, being a self-hostable open-source solution, offers complete control over data, security, and infrastructure, which cloud-native SaaS offerings may not provide. Complex workflow orchestration. For highly complex, multi-stage pipelines that involve intricate conditional logic, manual approvals, or cross-platform builds, Jenkins' mature pipeline capabilities, especially scripted pipelines, which we'll explore later, provide unmatched flexibility and power. Maturity and community support. Having been around for over a decade, Jenkins is a highly mature and robust platform. The sheer size of its user base and community means abundant documentation, troubleshooting guides, and immediate support. Practical application. Jenkins is often the preferred choice for organizations that already have significant on-premise infrastructure and want to leverage it. Need to integrate with a wide array of legacy systems or specialized tools. Require absolute control and customization over their CI/CD environment. Operate in highly regulated industries, demanding strict security and compliance audits on their build systems. Have very complex or highly unique build and deployment workflows that require maximum flexibility. While newer tools offer out-of-the-box simplicity for common use cases, Jenkins remains the heavyweight champion for flexibility, deep integration, and complete environmental control, making it a powerful and relevant choice for the foreseeable future. Summary. In this chapter, we've gained a deeper appreciation for Jenkins. We've learned that it's a powerful, open-source automation server that traces its roots back to the Hudson Project and a pivotal community fork. Its master agent architecture provides a robust and scalable foundation for orchestrating CI/CD workloads. Most critically, we've explored how its unparalleled plugin ecosystem and fundamental philosophy of extensibility allow it to adapt to virtually any development environment and integrate with an incredibly diverse set of tools. Understanding these core principles sets the stage for the practical steps we'll take in the next chapter, actively installing and configuring your very first Jenkins instance. Chapter 3. Getting started. Installing and configuring your first Jenkins instance. Having established the foundational concepts of CI/CD and Jenkins' central role, it's time to get hands-on. This chapter will walk you through the practical steps of installing and setting up your very first Jenkins instance. While specific commands and interface elements might vary slightly with Jenkins updates or your chosen operating system, the core principles and steps remain consistent. Our goal is to get Jenkins up and running so you can begin automating your projects. 3.1 System Requirements, what you'll need. Before you embark on the installation journey, it's good to understand the basic prerequisites for running Jenkins. While Jenkins can run on various systems, there are a few common requirements. Operating system. Jenkins is highly versatile and supports a wide range of operating systems, including Linux, various distributions like Ubuntu, Debian, Red Hat, CentOS. This is a very common choice for production Jenkins instances. Windows, Windows Server and desktop versions. macOS, popular for local development or small team setups. Java Development Kit, JDK. Jenkins is a Java application, so a compatible Java Development Kit, JDK, is an absolute must. As of this writing, Jenkins typically requires a recent long-term support, LTS, version of Java, such as Java 11 or Java 17. Ensure you have the JDK installed and configured correctly on the machine where you plan to run Jenkins. It's important to use the JDK, not just the Java Runtime Environment, JRE, as Jenkins may need compilation tools. Hardware recommendations, minimum for small instances. RAM, at least 256 MB, but 1 GB or more is strongly recommended for a responsive user interface and to handle a few concurrent small builds. For larger setups, this will need to be significantly more. CPU, a 1 GHz processor is a minimum, but a dual-core or quad-core processor will provide much better performance, especially when running multiple builds. Disk space, at least 1 GB for the Jenkins WAR file and plugins. However, allocate significantly more. 10 GB or more is a good starting point for storing build artifacts, job configurations, build histories, and workspace data. Builds can generate a lot of temporary files and outputs. Remember, these are minimums. For a production environment or a system handling many projects and builds, you'll need to scale up your resources accordingly. 3.2 Installation Options. One of Jenkins' strengths is its versatility in installation. You can choose the method that best suits your comfort level, operating system, and deployment strategy. Option 1. WAR File Deployment Basic. The Jenkins WAR Web Application Archive file is the simplest way to get Jenkins running quickly, especially for testing or small-scale use. A WAR file is a standard way to package web applications written in Java. To run the WAR file, you typically need a Java servlet container, such as Apache Tomcat. However, the Jenkins WAR file is self-contained and can be run directly using the Java jar Jenkins WAR command. This effectively starts an embedded Jetty servlet container that serves Jenkins. How it works. You download a single WAR file. Then, from your command line, you navigate to the directory where you saved the file and type a command that instructs Java to run that file. Jenkins will then start up, typically on port 8080. Pros: very quick to get started, requires minimal setup beyond having Java installed. Cons: not ideal for production environments, as managing the Java process and its backgrounding can be cumbersome. It also means you rely on Jenkins's embedded server rather than a fully configured and secured web server. Option 2. Native Packages, operating system specific. For more robust installations on Linux or Windows, Jenkins provides native packages. These are typically the recommended way to install Jenkins for long-term use in those environments, as they integrate better with the operating system's service management and update mechanisms. Linux. Jenkins provides apt for Debian/Ubuntu and yum for Red Hat CentOS repositories. This allows you to install Jenkins just like any other software package on your Linux distribution using standard commands. For example, on Ubuntu, you would add the Jenkins repository key, add the repository to your system sources, and then use apt-get install Jenkins. The system's service manager, like Systemd, would then manage Jenkins as a background service. Windows, a Windows installer is available, which guides you through the process and sets up Jenkins as a Windows service. This makes it easy to start, stop, and manage Jenkins from the Windows Services console. macOS. While PKG installers are available, many macOS users opt for community-maintained options like Homebrew for easier installation and management. Brew install Jenkins LTS. Pros: better integration with the operating system, easier service management, automatic startup on boot, and often more straightforward updates. Cons: less portable than a WAR file and tied to a specific OS. Option 3. Docker container, recommended for modern practices. For modern development and production environments, installing Jenkins via Docker is highly recommended. Docker allows you to package an application and its dependencies into a container, ensuring it runs reliably from one computing environment to another. This approach offers significant benefits. Isolation. Jenkins runs in its own isolated environment, preventing conflicts with other software on your host machine. Portability. A Docker image is highly portable. You can run the exact same Jenkins setup on any machine that has Docker installed. Reproducibility. You can easily create and recreate your Jenkins instance with a consistent configuration. Ease of setup. Once Docker is installed, running Jenkins is often a single, concise command. How it works: you'll need Docker installed on your system. You then pull the official Jenkins Docker image and run it. You usually map a volume from your host machine to the container's Jenkins home directory for persistent storage, ensuring your configurations and data aren't lost if you stop or restart the container. For example, a typical conceptual command would involve telling Docker to run this Jenkins image, map port 8080 from the container to my machine's port 8080, and store its data in a specific folder on my hard drive. This provides a clean, self-contained Jenkins environment. Pros: excellent for consistency, isolation, and portability. Simplifies moving Jenkins between different hosts or setting up new instances. Cons: requires an understanding of Docker concepts and having Docker installed. For the purposes of this book, we will proceed assuming you have successfully started Jenkins using one of these methods. The subsequent setup steps are largely the same regardless of your initial installation choice. If you are unsure, starting with the Docker method is often the quickest way to get a functional Jenkins instance for learning purposes. 3.3 Initial Setup Wizard Walkthrough. Once you've started Jenkins for the first time, either via the WAR file, a native service, or Docker, you'll be greeted by a web-based setup wizard in your browser, typically at http localhost:8080. This wizard guides you through the essential initial configurations. Unlocking Jenkins. The first step is a security measure. Jenkins will ask for an initial admin password. This password is automatically generated and is stored in a specific file within your Jenkins home directory or in the console output where Jenkins was launched. You'll need to locate this password. For Linux or Docker, you can often find it by viewing the Jenkins startup logs, e.g., sudo cat/var/lib/jenkins/secrets/initial admin password, or by inspecting the Docker container logs. On Windows, it's typically in a log file within the Jenkins installation directory. Copy this alphanumeric password and paste it into the provided field in the browser. This grants you temporary administrative access to complete the setup. Install plugins. After unlocking, Jenkins will present you with two options for installing plugins. Install suggested plugins. This is the recommended choice for most new users. Jenkins will automatically install a curated set of popular and essential plugins that cover common functionalities like Git integration, Maven support, pipeline capabilities, and email notifications. This is a great starting point, ensuring you have the core features you'll likely need. Select plugins to install. This option allows you to manually choose which plugins to install from a complete list. While it offers more control, it's best for experienced users who know exactly what they need and want to avoid unnecessary plugins. Choose Install Suggested Plugins. Jenkins will then download and install these plugins, which may take a few minutes depending on your internet connection. Create First Admin User. Once the plugins are installed, Jenkins will prompt you to create your first administrator user. This is no longer the temporary initial password. Provide a strong username, password, full name, and email address for your primary Jenkins administrator account. This account will have full access to manage Jenkins. Important, remember these credentials. This is how you'll log in to Jenkins going forward. Instance configuration, Jenkins URL. Finally, Jenkins will ask you to set the Jenkins URL. This is the base URL that Jenkins will use for itself and for generating links, e.g., in notification emails. For a local setup, http localhost:8080 might be fine. However, if you plan to access Jenkins from other machines, or if it's running on a server, you should enter its public IP address or DNS hostname, e.g., http://jenkins-server.com:8080. Click Save and Finish to complete the setup. Congratulations! You should now be on the Jenkins dashboard, ready to start creating your first automation jobs. 3.4 Navigating the Jenkins User Interface. Upon successful setup, you'll land on the Jenkins dashboard. Getting familiar with its layout is essential for working with Jenkins effectively. The main dashboard, Welcome Message. At the top, you'll see a welcome message. Build history. Typically on the left or center, this section shows a chronological list of recent builds, their status, success, failed, unstable, and how long they took. Build queue. If jobs are waiting to be executed, they'll appear here. Executor status. This shows how many concurrent builds Jenkins can run and how many are currently busy. Weather icon and ball color. A visual indicator next to each job, showing the stability trend, e.g., sunny for consistently stable, stormy for frequent failures. The status ball, blue for success, red for failure, yellow for unstable, quickly tells you the last build result. The left-hand navigation pane, this is your primary navigation hub. New item, this is where you'll go to create new Jenkins jobs or pipelines. People, shows a list of users who have interacted with Jenkins, e.g., triggered builds. Build history, a consolidated view of all recent builds across all jobs. Manage Jenkins, this is the administrative heart of your Jenkins instance. You'll spend a lot of time here configuring system settings, managing plugins, and setting up security. My Views allows you to create customized dashboards to organize your jobs. Credentials manages sensitive information like passwords, API tokens, and SSH keys used by Jenkins jobs. The Manage Jenkins section, the admin hub. Clicking Manage Jenkins in the left-hand navigation pane opens up a crucial set of administrative links. This is where you configure Jenkins global settings, install plugins, set up security, and manage your nodes and agents. Some key sections include: System configures global settings for your Jenkins instance, such as its URL, email notifications, quiet period, delay before builds, and global properties. Global tool configuration. This is where you tell Jenkins about the locations of essential development tools like JDKs, Git, Maven, and Gradle. Plugins, the gateway to extending Jenkins functionality. You can install, update, and manage all your installed plugins here. Security configures user authentication, authorization, who can do what, and global security settings. Nodes manages your Jenkins master and any connected agent machines. Take some time to explore the interface. Click around, see what's behind each link. Familiarity with the UI will significantly speed up your work with Jenkins. 3.5 Basic Global Configurations. Before you start creating jobs, it's often a good practice to set up some basic global configurations that will be used by many of your projects. These are managed under Manage Jenkins Global Tool Configuration. Let's look at how to configure popular development tools. JDK, Java Development Kit. Even if you have Java installed on the machine running Jenkins, you need to tell Jenkins about it so your build jobs can use it. In Global Tool Configuration, find the JDK section. You have two main options. Install automatically. This is often the easiest. Jenkins can download and install a specific version of Java for you. Check the box, give it a name, e.g., JDK 11 or JDK 17, and select the desired version. You'll need to accept the license agreement. Jenkins will manage the installation. Add JDK home. If you have a specific JDK installation on your system or agents, you can point Jenkins to its home directory. Provide a name and the path to the JDK's root folder. Click Apply or Save after making changes. Git. Most projects today use Git for source code management. Jenkins needs to know where the Git executable is located. In Global Tool Configuration, find the Git section. Similar to JDK, you can usually select Install Automatically, and Jenkins will download a recent Git client. Alternatively, if Git is already installed on your Jenkins server or agents, you can specify its path. Maven. If you're working with Java projects using Maven for building, you'll need to configure Maven. In Global Tool Configuration, find the Maven section. Again, Install Automatically is the simplest approach for beginners. Give it a name like Maven 3.8. These automatically installed tools will be managed by Jenkins and become available for your jobs. Configuring these global tools once saves you from having to specify them for every single job, making your job configurations cleaner and more maintainable. 3.6 Common pitfalls during installation. Even with a wizard, you might encounter issues during installation or initial setup. Here are some common pitfalls and troubleshooting tips. Java version incompatibility. Problem: Jenkins startup fails, or it throws errors related to Java version. Solution: ensure you have an appropriate LTS JDK, e.g., Java 11 or Java 17, installed and properly configured in your system's path environment variable. Remember, Jenkins needs the JDK, not just the JRE. Double-check the exact Java version required by your Jenkins version, as this can change over time. Firewall issues. Problem: you can't access Jenkins in your web browser, or agents can't connect to the master. Solution: by default, Jenkins runs on port 8080. Your operating system's firewall might be blocking this port. You'll need to add an inbound rule to allow traffic on port 8080, or whatever port Jenkins is configured to run on. On Linux, this might involve UFWA or firewalled commands. On Windows, it's done through Windows Defender firewall settings. Port conflicts. Problem: Jenkins fails to start, complaining that port 8080 is already in use. Solution: another application on your machine is likely using port 8080. You can either stop the other application, configure Jenkins to run on a different port, e.g. 9090. How you change the port depends on your installation method, e.g., an argument to Java, jar Jenkins war, a configuration file for native packages, or a Docker run command parameter. Permissions issues. Problem. Jenkins can't write to its home directory, /var/lib/Jenkins on Linux, users home on Windows Mac OS, or execute scripts. Solution. Ensure the user account under which Jenkins is running has full read, write, and execute permissions to its entire home directory, and any workspaces it needs to access for builds. This is particularly common on Linux, where you might need to adjust ownership, chown, or permissions, chmod. Insufficient disk space. Problem. Builds fail unexpectedly, or Jenkins becomes unresponsive after running a few jobs. Solution. Check the disk space on the volume where Jenkins stores its data, Jenkins. Builds generate temporary files, and artifacts can consume a lot of space. Regularly clean up old build history or configure jobs to discard old builds. How to check Jenkins logs. When troubleshooting, your first stop should always be the Jenkins logs. These logs provide valuable insights into what's happening during startup, job execution, and any errors encountered. War file. Logs are usually printed directly to the console where you ran the Java jar command. Native package, Linux. Logs are typically found in var/log/Jenkins/Jenkins log. You can view them using tail fvar/log/Jenkins/Jenkins log. Native package, Windows. Logs are usually within the Jenkins installation directory, C, \program files \Jenkins out or similar. Docker. You can view container logs using Docker logs container name. By understanding these common issues and how to check your Jenkins logs, you'll be well equipped to troubleshoot effectively and keep your Jenkins instance healthy. Summary. You've successfully taken the crucial first step into the world of CI/CD with Jenkins. This chapter covered the essential system requirements, walked you through the different installation methods, war, native packages, and Docker, and guided you through the initial setup wizard. We also explored the key sections of the Jenkins user interface and configured some basic global tools like JDKs and Git. Finally, we equipped you with knowledge of common pitfalls and how to troubleshoot them. Your Jenkins instance is now ready to perform its first act of automation, which we'll tackle in the next chapter, building your very first Jenkins job. Chapter 4, Your First Automation, Building a Simple Jenkins Job. With your Jenkins instance up and running, the next exciting step is to put it to work. This chapter will guide you through creating your very first automated task, what Jenkins calls a job or item. We'll start with the simplest type of job, a freestyle project, which is excellent for understanding the core concepts of job configuration before moving to more advanced topics. 4.1 Understanding Jenkins Jobs, Items. In Jenkins, a job or item is the fundamental unit of work that Jenkins performs. Each job defines a specific automated task, such as compiling code, running tests, or deploying an application. Jenkins offers several types of jobs, each suited for different purposes. Freestyle project. This is the most basic and flexible type of job. It provides a highly configurable graphical user interface where you can combine arbitrary build steps, like executing shell commands or invoking build tools and post-build actions. It's excellent for simple, single-purpose automation tasks and for getting started with Jenkins. Pipeline. This is a more advanced and powerful job type, which we will dedicate an entire chapter to later. Pipelines allow you to define your entire CI/CD workflow as code, typically in a file called a Jenkins file stored alongside your project's source code. This offers version control, reusability, and detailed visualization of complex workflows. Multi-configuration project, matrix project. Designed for running the same build logic on different combinations of variables, e.g., testing software across multiple operating systems, JDK versions, or browser types. Folder, not a job type for execution itself, but a way to organize your jobs into logical groups, helpful for larger Jenkins instances. For our first automation, we'll focus on the freestyle project to introduce the core concepts in a digestible manner. 4.2. Creating a freestyle project. Let's create a very simple Hello Jenkins job that just prints a message. This will demonstrate the process of creating and configuring a job. Navigate to the Jenkins dashboard. Log into your Jenkins instance. You should be on the main dashboard. Click New Item. In the left-hand navigation pane, click on New Item. Enter item name. You'll be prompted to enter an item name. Choose something descriptive like My First Hello World Job. It's good practice to use hyphens or underscores instead of spaces, as this can prevent issues with some build tools or scripts. Select Freestyle Project. From the list of options, select Freestyle Project. Click OK. This will take you to the configuration page for your new job. Now you're on the job configuration screen. This might look a bit overwhelming at first, but we'll break it down section by section. At the top, you'll see a text area for a description. It's always a good idea to add a brief description of what the job does, especially as you start creating more jobs. For instance, this job prints a simple Hello Jenkins message to the console. For now, we'll skip the source code management and build triggers sections and jump straight to defining what the job does. 4.3 Source Code Management, SCM Integration. While our Hello World job doesn't strictly need source code, most real-world CI/CD jobs do. Jenkins integrates seamlessly with various source code management, SCM, systems like Git, Subversion, SVN, and Mercurial. Git is by far the most prevalent in modern development. Let's imagine you have a simple project hosted on GitHub that you want Jenkins to build. You would configure the source code management section in your job akin to this. Select SCM type. In the job configuration page, find the source code management section. Select Git. Repository URL, you'll see a field for repository URL. This is where you paste the URL of your Git repository, e.g., https://github.com/your-username/your-repo-git. Credentials, if your repository is private, Jenkins needs credentials to access it. Click Add next to the Credentials dropdown. You can add a username with password for basic Git authentication, SSH username with private key for SSH-based access, or an API token for platforms like GitHub GitLab. Provide a descriptive ID for your credentials and add them. Then, select those credentials from the dropdown. Branches to build. The Branches to build field defaults to master or main. This tells Jenkins which branch or branches to monitor and build. You can change this to develop or a specific branch like feature new login. Once configured, Jenkins will automatically fetch the code from the specified repository and branch every time it starts a build for this job. This ensures your builds always operate on the most up-to-date version of your source code. 4.4 Build Triggers. When should Jenkins build? A key aspect of automation is defining when a job should run. Jenkins provides several ways to trigger a build. Build Now, Manual Trigger. This is the simplest way to run a job. On the job's main page in Jenkins, you'll see a Build Now link in the left-hand navigation. Clicking this immediately starts a build. This is great for testing your configuration or running an on-demand deployment. Poll SCM. This trigger instructs Jenkins to periodically check your SCM repository for changes. If Jenkins detects any new commits since the last build, it will trigger a new build. You define the polling frequency using a cron-like syntax, e.g., H5 means check every 5 minutes. While simple, this can be inefficient as Jenkins constantly checks, even if there are no changes. GitHub hook trigger for Git SCM polling or generic webhook trigger, etc. This is a much more efficient and modern way to trigger builds on SCM changes. Instead of Jenkins constantly asking the SCM if there are changes, the SCM, e.g., GitHub, GitLab, Bitbucket, tells Jenkins when a change occurs. This is done using a webhook. When a developer pushes code, the SCM sends a small HTTP request to a specific URL on your Jenkins instance, instantly triggering a build. This provides faster feedback and reduces unnecessary polling. You'll typically configure the webhook URL in your SCM repository settings. Build periodically. This trigger runs a job at specified intervals, regardless of whether there are any SCM changes. This is configured using cron syntax, e.g., 00 to build every day at midnight. This is useful for nightly builds, generating reports, or running scheduled cleanup jobs. Build after other projects are built. This allows you to chain jobs together. If job A successfully completes, it can trigger job B. This is useful for setting up dependencies, like running an integration test job only after a build job has successfully created an artifact. For our Hello World job, we won't configure any automatic triggers initially, relying on Build Now for manual execution. 4.5 Build Steps. What should Jenkins do? This is where you define the actual work your Jenkins job will perform. In a freestyle project, this is done by adding build steps. Navigate to the Build section. In your job's configuration page, scroll down to the Build section. Click Add Build Step. A drop-down menu will appear showing various options. The most common and flexible are Execute Shell for Linux Mac OS. Allows you to type any shell commands that will be executed in the build environment. Execute Windows Batch Command for Windows allows you to type any batch commands for Windows environments. Invoke top-level Maven targets. If you're building a Java Maven project, this step integrates directly with Maven. Invoke Gradle script for Gradle projects. For our Hello World job, we'll use Execute Shell, assuming a Linux-based Jenkins setup, or Execute Windows Batch Command if on Windows. Add a simple command, select Execute Shell. A text area will appear. Type the following command, echo hello Jenkins, this is my first automated build. If you're on Windows and selected Execute Windows Batch Command, you would type, echo hello Jenkins, this is my first automated build. Save your job, scroll to the bottom of the page and click Save. You've now configured your first Jenkins job. It's very basic, but all complex CI/CD pipelines in Jenkins start with these fundamental building blocks. 4.6 Post-build actions. What happens after the build? After the build steps are executed, Jenkins can perform post-build actions. These actions are executed regardless of whether the build step succeeded or failed, though you can configure them to run only on success or failure. Common post-build actions include archiving artifacts. This is crucial for saving the outputs of your build, e.g., compiled jar war files, executable binaries, deployment packages, Docker images. Jenkins stores these artifacts, making them accessible from the build history page. If you need to deploy an application, you'll first archive its built artifact. Email notification. Send an email to specified recipients on build failure, success, or other conditions. Publish JUnit test result report. Process and display test results from your automated tests, making them visible in the Jenkins UI. Trigger other projects. As mentioned in build triggers, start another job if this one finishes successfully. Let's add a simple post-build action. Go back to job configuration. From your My First Hello World job main page, click Configure in the left-hand navigation. Scroll to Post-build actions, find this section at the bottom. Click Add Post-build action, select Email notification. Configure email. In the Recipients field, enter your email address. You can also specify conditions for when to send the email, e.g., only on failure or always. For this example, you might choose every unsuccessful build. Save the job again. Now, if your build were to fail, which won't happen with our simple echo command, Jenkins would attempt to send an email notification as configured. For email notifications to work, you'll need the Mailer plugin installed and SMTP server details configured in Manage Jenkins system. 4.7 Running and monitoring your first job. Now that your job is configured, it's time to run it and observe the results. Trigger the build. Navigate back to the main page of your My First Hello World job if you're not already there after saving. In the left-hand navigation, click Build Now. Observe build history. In the Build History section on the left-hand side, a new build number will appear, e.g., 1. A small animation might show a progress bar as the build runs. Access console output. Once the build is complete, the progress bar disappears, and the build number shows a colored status ball. Click on the build number, e.g., 1. This takes you to the build's dedicated page. On this page, click Console Output in the left-hand navigation. This is the real-time log of everything your job did. You should see output similar to this. started by your admin user. Running as your admin user. Env inject, loading node environment variables. Building in workspace var /lib/jenkins /workspace /my first hello world job. My first hello world job. /bin /shztmp /jenkins x8. Echo hello Jenkins. This is my first automated build. Hello Jenkins, this is my first automated build. Finished. Success. You can see the echo command was executed and its output was printed. Finished. Success indicates the build completed without errors. Understanding build status, blue ball or green in some themes. Success, the build completed successfully. Red ball, failed, the build encountered an error and did not complete successfully, e.g., code compilation error, test failures. Yellow ball, unstable, the build completed, but with warnings or some tests failed, while the main build succeeded. Gray ball, abortad, the build was manually stopped or terminated by Jenkins, e.g., due to a timeout. Spinning ball or progress bar, the build is currently running. Back on the job's main page, you'll notice the status ball next to the last build and a weather icon, a little sunny icon if it's always succeeding. The last success and last failure timestamps are also updated. By running this simple job, you've touched upon the core elements of configuring jobs in Jenkins, defining what code to use SCM, specifying what actions to perform build steps, and deciding what happens afterward, post-build actions. Summary. You've successfully created, configured, and run your first Jenkins job. This Hello World example, while simple, demonstrated the fundamental concepts of Jenkins jobs. Understanding different job types, configuring source code management. Conceptually, setting up build triggers, defining build steps, and adding post-build actions. Crucially, you learned how to run a build and interpret its console output and status. In the next chapter, we'll dive into the world of Jenkins pipelines, a more powerful and code-centric approach to defining your CI/CD workflows, which will open up possibilities for much more complex and robust automation. Chapter 5, Embracing Pipeline, Introduction to Jenkins Pipelines. In the previous chapter, you successfully created and ran your first freestyle Jenkins job. While freestyle jobs are great for simple tasks and initial learning, they quickly hit limitations when dealing with complex, multi-stage, or version-controlled CI/CD workflows. This is where Jenkins pipelines come into play. This chapter introduces you to the concept of pipeline as code, explaining why it's a superior approach for modern software delivery and guiding you through creating your first Jenkins pipeline using the declarative syntax. 5.1. The evolution from jobs to pipelines. Imagine a scenario where your software delivery involves multiple steps: compiling code, running unit tests, performing integration tests, building a Docker image, pushing it to a registry, and finally deploying it to a testing environment. With freestyle jobs, you might create several interconnected jobs where one job triggers the next. For example, a build job that compiles code, a test job that runs tests after the build job succeeds, a deploy job that deploys after test succeeds. While functional, this approach has several drawbacks. Lack of version control. The configuration of a freestyle job is stored within Jenkins' internal XML files. It's not version controlled alongside your application code. This makes auditing changes difficult, reverts challenging, and sharing configurations across multiple projects cumbersome. Limited visibility and orchestration. It's hard to visualize the entire workflow. If one job in a chain fails, understanding where and why the process stopped requires navigating through multiple Jenkins screens. Orchestrating parallel tasks or complex conditional logic becomes highly challenging. Manual and error-prone setup. Setting up interconnected freestyle jobs is often a manual process through the UI, making it prone to human error and difficult to reproduce exactly. Limited reusability. Reusing parts of an existing workflow for a new project often means manually copying and pasting configurations, leading to inconsistencies. These limitations make managing and scaling CI/CD processes with multiple freestyle jobs impractical for anything beyond the simplest scenarios. This is what led to the development of Jenkins pipelines. 5.2. What is a Jenkins pipeline? A Jenkins pipeline is a suite of plugins that supports implementing and integrating continuous delivery pipelines into Jenkins. At its core, a Jenkins pipeline allows you to define your entire application delivery workflow as code. This pipeline as code approach is typically achieved by placing a text file named Jenkins file, case-sensitive, directly into the root directory of your project's source code repository. The Jenkins file contains the entire definition of your CI/CD pipeline, specifying stages, steps, and conditions for your automation. The benefits of adopting the pipeline as code approach are significant. Version control. Since the Jenkins file lives in your SCM, e.g., Git, alongside your application code, your entire delivery pipeline is now version controlled. You can track changes, revert to previous versions, and understand who changed what and when. Auditability. Every change to the pipeline is recorded in your SCM, making it easy to audit and trace. Repeatability and determinism. The Jenkins file guarantees that the pipeline will execute the exact same way every time it's run, ensuring consistency across environments and preventing "it worked on my machine" issues. Reusability. You can define common pipeline patterns in shared libraries, which we'll discuss in a later chapter, and reuse them across multiple projects, promoting best practices and reducing duplication. Visibility and visualization. Jenkins provides excellent visualizations for pipelines, allowing you to see the progress through different stages, identify bottlenecks, and quickly pinpoint where a failure occurred. The stage view in Jenkins gives you a clear graphical representation of your entire pipeline flow. Collaboration. Developers, QAs, and operations teams can collaborate on defining and refining the pipeline logic directly within the version control system. In essence, Jenkins pipelines transform your CI/CD process from a series of disjointed graphical configurations into a cohesive, version-controlled, and highly transparent workflow. 5.3 Declarative versus scripted pipeline. Jenkins pipelines can be written in two syntaxes, declarative and scripted. Both are built on Groovy, a powerful scripting language for the Java platform, but they offer different levels of abstraction and flexibility. Declarative pipeline. Syntax. Designed to be simpler, more structured, and less error-prone. It provides a predefined structure with specific sections for pipeline, agent, stages, stage, steps, and post-actions. Ease of use. Easier for beginners to learn and read because of its opinionated structure. It enforces a consistent layout. Use cases. Ideal for most common CI/CD scenarios where you need a clear, sequential flow with some conditional logic. This is the recommended style for new Jenkins pipeline users. Focus. Expressing what you want to achieve. Scripted pipeline. Syntax. More flexible and powerful, resembling traditional Groovy scripting. It uses a node block as its primary container. Ease of use. Steeper learning curve due to the direct Groovy programming. Requires a better understanding of Groovy language constructs. Use cases. Suited for highly complex, custom workflows, or when you need robust programmatic logic, error handling, or direct manipulation of Jenkins' internal APIs. Focus. Expressing how you want to achieve it, offering fine-grained control. For this book, we will primarily focus on the declarative pipeline syntax. It offers sufficient power and flexibility for most modern CI/CD needs while being significantly easier to grasp and maintain. It's the recommended starting point for anyone new to Jenkins pipelines. 5.4 Anatomy of a declarative pipeline, Jenkins file. A declarative pipeline is structured to be readable and understandable at a glance. Let's break down its core components that reside within your Jenkins file. This is your Jenkins file. Pipeline, the root block of a declarative pipeline. Agent any defines where the entire pipeline will run. Stages contains one or more stage blocks. Stage build, a named section for a logical set of steps. Steps contains one or more individual commands or actions. Echo building the application, a simple step. Print a message. sh mvn clean install, example. Execute a shell command for Maven build. Stage test. Steps. Echo running tests. Sh npm test, example. Execute a shell command for npm tests. Optional. Actions to perform after all stages have completed. Post. Always, this block always executes. Echo pipeline finished. Success. This block executes only if the pipeline succeeds. Echo pipeline completed successfully. Failure. This block executes only if the pipeline fails. Echo pipeline failed. Let's dissect these key directives. Pipeline. This is the mandatory top-level block that encompasses the entire declarative pipeline. All other directives and elements must reside within this block. Agent. This directive specifies where the pipeline or a particular stage will execute. Agent any. This tells Jenkins to execute the pipeline on any available agent. Other options include agent none, implies each stage must specify its own agent, agent label my Linux agent, run on an agent with a specific label, agent Docker, run the pipeline within a Docker container, and agent Kubernetes, run stages as pods on Kubernetes. Stages. This mandatory block contains one or more stage directives. It defines the sequential logical divisions of your delivery process. Jenkins will execute these stages in the order they are defined. Stage name. Each stage block represents a distinct phase of your CI/CD process, e.g., build, test, deploy, security scan. Stages are typically executed sequentially. They provide a clear visual breakdown in the Jenkins UI. Steps. This mandatory block is nested within a stage block and contains one or more step directives. A step is a single task or command that Jenkins performs. Examples include echo hello world, prints a message to the console output. sh command line command executes a shell command for Linux Mac OS agents. Bat command line command executes a batch command for Windows agents. Git https github.com/my/repogit clones a Git repository. Junit/target/xml publishes JUnit test results, and many more provided by Jenkins core and plugins. Post. This optional block defines actions that run after all stages in the pipeline have completed, regardless of whether the pipeline succeeded or failed. You can define various post conditions like always, success, failure, unstable, aborted, and changed, allowing for conditional cleanup or notification actions. 5.5 Your first declarative pipeline. A simple build test. Let's put this knowledge into practice by creating a very simple pipeline that mimics a basic build and test scenario. We'll simulate these steps with echo commands for now. Practical application. Create a sample repository or use an existing one. You'll need a Git repository for this. You can create a new empty repository on GitHub GitLab or use a local one. The critical step is to add a file named Jenkins file to its root. Jenkins file content, Jenkins file, pipeline, agent any, stages, stage checkout code, steps, echo checking out source code, git https github.com/jenkins-docs/simple-java-maven-appgit. Replace with your repo if needed. Stage build application. Steps, echo starting the application build. mvn clean package dskip tests, assuming a Maven project. Skips tests to keep it simple. Stage run unit tests. Steps, tag equals sh, return a stdout, true script, echo n running unit tests. Trim, echo tag, mvn test. For a real Maven project, you'd run tests. For a simplified example, we'll just echo some text. Echo tests pass successfully simulated. Post. Always. Echo pipeline execution complete. Success. Echo congratulations, build and tests passed. Failure. Echo oops, something went wrong in the pipeline. Commit and push. Save this Jenkins file in the root of your Git repository and push it to your remote SCM. Create a new pipeline job in Jenkins. Log into your Jenkins dashboard. Click New Item in the left-hand navigation. Enter an item name, e.g. My First Pipeline Project. Select Pipeline as the project type. Click OK. Configure the pipeline job. Provide a description, e.g. a simple Jenkins pipeline for building and testing an application. Scroll down to the pipeline section. For definition, choose Pipeline Script from SCM. This tells Jenkins to look for the Jenkins file in your source code repository. For SCM, select Git. In repository URL, paste the URL of your Git repository, e.g., https://github.com/your-username/your-repo-git. If your repository is private, configure credentials as you did in Chapter 4. Branches to build should remain main or master unless you're working on a different branch. Script path should remain Jenkins file. This is the default name, but if your file had a different name, e.g. CI pipeline Groovy, you would specify it here. Click Save. Run the pipeline. You'll be directed to the job's main page. Click Build Now in the left-hand navigation. The pipeline will start running. View the stage view. As the pipeline runs, you'll see a graphical representation called the stage view appear below the build history on the job's main page. This view provides a real-time visual progress indicator of your pipeline through its defined stages. Each successful stage will turn green, while a failing stage would turn red. Click on a stage icon or the build number, and then Console Output to view the detailed logs for that specific build. You should see the echo messages and the simulated build test output. This simple pipeline showcases the sequential execution of stages and the immediate feedback provided by the stage view. You've now experienced the power of defining your CI/CD workflow as code right inside your project repository. 5.6 Understanding the Blue Ocean UI, optional but beneficial. While the default Jenkins UI's stage view is functional, the Blue Ocean plugin provides a much more modern, intuitive, and visually appealing user experience specifically designed for Jenkins pipelines. It offers improved pipeline visualization, clear animated visualizations of your pipeline's flow, showing stages, steps, and their status in real time. Intuitive troubleshooting. Easily pinpoint failures and navigate directly to the specific log lines for failed steps. Git and branch integration. Better support for visualizing multi-branch pipelines and pull request builds. Simplified job creation. A wizard-like interface for pipeline creation. How to get it? If you don't have it installed already, it's often suggested with default plugin installations. Go to Manage Jenkins Plugins Available Plugins, search for Blue Ocean, install it, and restart Jenkins if prompted. Once installed, you'll see a Open Blue Ocean button link in the left-hand navigation pane on your Jenkins dashboard. Clicking it will take you to the Blue Ocean interface, where you can see your pipelines vividly displayed. While not strictly necessary for this book, it's highly recommended for a better Jenkins pipeline user experience. Summary. This chapter marked a significant leap forward in our Jenkins journey. You've moved from basic freestyle jobs to the powerful pipeline as code paradigm. We distinguished between freestyle jobs and pipelines, highlighting the benefits of version-controlled, auditable, and reusable pipeline definitions. We explored the two main pipeline syntaxes, declarative and scripted, and chose to focus on the easier-to-understand declarative syntax. Finally, you learned the anatomy of a Jenkins file and successfully created and ran your first declarative pipeline, observing its execution in the intuitive stage view. In the next chapter, we'll build upon this foundation, diving deeper into advanced directives and steps to create even more robust and capable Jenkins pipelines. Chapter 6. Building Robust Pipelines. Advanced Stages and Steps. In the previous chapter, you created your first declarative pipeline, a significant step towards automating your CI/CD workflow. While that basic pipeline demonstrated the concept of stages and steps, Jenkins offers a rich set of directives and functions that allow you to build incredibly robust, flexible, and intelligent pipelines. This chapter will delve deeper into these advanced features, enabling you to construct more capable and resilient automation strategies. 6.1 Intelligent Agent Placement. More about agent directives. The agent directive specifies where a pipeline or a specific stage will execute. In Chapter 5, we used Agent Any, which told Jenkins to run the entire pipeline on any available agent. Let's explore more sophisticated uses of the agent directive. Agent None. If you use Agent None at the top-level pipeline block, it means the entire pipeline won't run on a single, dedicated agent. Instead, each individual stage within your pipeline must specify its own agent directive. This is useful when different stages require different execution environments. For example, a build stage might run on a Linux agent, while a security scan stage runs inside a specific Docker container. Agent, label, your agent label. You can target specific agents by assigning them labels in their configuration. For instance, you might have agents labeled Linux build, Windows test, or GPU accelerated. By specifying an agent with a label, you ensure that the pipeline or stage runs only on an agent that possesses that specific label. This is crucial for matching job requirements to available resources. You'd include this label directive inside the agent block. Agent, Docker, image, Maven, 3.8.5 JDK 11. Conceptual. For even greater build reproducibility and isolation, Jenkins allows you to run your pipeline steps directly inside a Docker container. When you specify agent, Docker, image, your image, Jenkins will dynamically spin up a Docker container using the specified image, execute your pipeline steps within that container, and then discard the container once the job is done. This ensures a clean, consistent, and isolated build environment for every run, protecting your host system from build tool installations and version conflicts. We'll explore containerized agents more in Chapter 8. Agent, Kubernetes, Cloud Kubernetes. Conceptual. Similarly, if your Jenkins is integrated with a Kubernetes cluster, you can tell Jenkins to provision a temporary Kubernetes pod, a small unit of deployment in Kubernetes, to run your build steps. This offers highly scalable and ephemeral build environments, leveraging your Kubernetes infrastructure. This is also a topic we'll touch upon further in Chapter 8. The ability to specify agents at both the pipeline and stage level gives you granular control over where each part of your CI/CD workflow executes, optimizing resource usage and ensuring the right tools are available for each task. 6.2 Orchestrating workflows, organizing your stages. A well-structured pipeline is easy to read, understand, and debug. Beyond simply listing stages sequentially, you can organize them to reflect independent logical units of work that might even run concurrently. Logical separation. Good pipeline design dictates that each stage should represent a distinct, meaningful phase of your software delivery. Common stage names include pull request check, build, unit tests, integration tests, code quality scan, deploy to development, deploy to staging, and deploy to production. This clear separation helps in tracing issues and maintaining the pipeline. Parallel stages. Sometimes, certain tasks within your pipeline don't depend on each other and can be executed at the same time to save valuable build time. Jenkins pipelines support running stages in parallel. For example, after a successful build stage, you might want to run your unit tests and code quality scan simultaneously. The syntax for parallel is straightforward. You place stage blocks inside a parallel block within your stages section. Practical application. Parallel testing. Consider a scenario where you have separate sets of unit tests and integration tests. Instead of running them one after another, you can execute them in parallel. Pipeline, agent, stages blocks. Stage build artifact. Steps. Echo building the application. SH MVN clean package, dskip tests. Stage test and scan parallel. Parallel, this block contains stages that will run concurrently. Stage run unit tests. Steps. Echo executing fast unit tests. SH MVN test dsuit equals unit. Example command. Stage perform code scan. Steps. Echo running code quality analysis. SH sonar scanner. Example command. Stage deploy if all pass. Steps. Echo deploying application to staging. sh/deploy sh staging. Post block. In this conceptual pipeline, the run unit tests and perform code scan stages would execute at the same time, significantly reducing the overall pipeline runtime compared to running them sequentially. 6.3 Powerful actions. Advanced steps and scripting within pipelines. While Echo and SH are fundamental, Jenkins pipelines offer many more ways to perform actions and control flow. Environment variables. Pipelines have access to a rich set of environment variables. Some are provided by Jenkins itself, e.g., buildid, jobname, workspace, and you can also define your own. These are often used to pass information between steps or stages or to configure build tools. You access them using the env object, echo build number, NVBULDNUMBR, conditional execution with when directive. The when directive allows you to specify conditions under which a stage should execute. This is incredibly powerful for creating dynamic pipelines that adapt to different situations. Common conditions include when branch main. Only run this stage if the current branch being built is main. When expression return params .deploytoprod equals true, only run if a build parameter deploytoprod is set to true. When environment name CI value true, only run if a specific environment variable is set. Practical application conditional deployment. You might want to deploy to production only when changes are merged into the main branch. Pipeline agent stages blocks. Stage deploy to staging. Steps. Echo deploying to staging environment. Stage deploy to production. When branch main, only execute this stage if the branch is main. Steps. Echo deploying to production environment. Post block waiting for input. The input step. Sometimes a human decision is required before a pipeline can proceed. This is common for manual approvals before deploying to a production environment. The input step allows you to pause the pipeline and wait for user confirmation. Stages blocks. Stage, manual approval for production. Steps. Input. Message, deploy to production. Click Proceed to continue. OK, yes, deploy. Custom text for the Proceed button. Add parameters if you need user input, e.g., deploy tag. Version. Echo, manual approval received. Proceeding with production deployment. Stage, deploy to production. Steps for production deployment. Post block. When Jenkins reaches the input step, the pipeline execution will pause, and a clickable link will appear in the Jenkins UI, and often in blue ocean, allowing a user with appropriate permissions to approve or reject the continuation. 6.4 Data Management. Handling build artifacts and test results. A build often produces important output files, known as artifacts, and generates test results that you want Jenkins to record and display. Archive artifacts. This step saves selected files from your workspace as build artifacts. These artifacts are attached to the build history and can be downloaded later. This is crucial for preserving compiled binaries, warjar files, configuration files, or any other output needed for subsequent deployments or debugging. Within a stage after compilation. Steps. SHMVN clean package. Archive artifacts, target jar, fingerprint, true. Echo archive jar file. The fingerprint, true option is useful for tracking which builds produced which artifacts, creating a link between them. JUnit. If your project generates test reports in the JUnit XML format, which many testing frameworks do, the JUnit step allows Jenkins to parse these reports, display test results graphically, and track test trends over time. Within a test stage, steps. SHMVN test. JUnit/target/surefire reports/XML, path to your JUnit XML reports. Echo published JUnit test results. This step enables the test result link on your build page, showing past, failed, and skipped tests. Other reporters. Jenkins also has steps for other types of reports, such as Cucumber for Cucumber BDD reports, enabling similar visualization and tracking. 6.5 Resilient workflows. Error handling and notifications. Even the most robust pipelines can fail. It's essential to handle failures gracefully and ensure relevant team members are informed. The post section of your declarative pipeline is designed for this. The post section can contain several blocks, each executing under different conditions. Always executes regardless of the pipeline's outcome, success, failure, unstable, aborted. Useful for general cleanup or logging. Success executes only if the pipeline completes successfully. Failure executes only if the pipeline fails. Unstable executes if the pipeline is unstable, e.g., tests failed but the build itself completed. Aborted executes if the pipeline was manually aborted. Changed executes if the pipeline status changed since the last build, e.g., from failed to success or vice versa. Practical application. Sending different notifications. You can use these conditions to send specific notifications based on the pipeline's outcome. A Jenkins file, post. Always Echo pipeline execution has completed. Success. Mail to devs@example.com. Subject success. NVJOBNAME build NVBULDNUMBR. Body the build passed. Check details at NVBULD URL. Echo success email sent. Failure. Slack send channel. DevOps alerts. Color danger. Message failure. NVJOBNAME build NVBULDNUMBR failed. See console output at nvbuilder/console. Echo failure alert sent to Slack. You could add other conditions for unstable or aborted. Note, for mail and Slack send or similar notification steps, you'll need the appropriate plugins installed, Mailer plugin and Slack notification plugin, respectively, and configured globally in Jenkins. 6.6 Making pipelines flexible. Parameterized builds. A pipeline's flexibility increases significantly if you can pass input values at the time of execution. Parameterized builds allow users to provide values, like environment names, version numbers, or Boolean flags, directly from the Jenkins UI when they trigger a build. To define parameters, you use the parameters directive within the pipeline block. Pipeline. Agent any. Parameters. String name, trgtmvronment, default value. Staging, description. The environment to deploy to staging or production. Boolean param name. RUNFULLTSDS, default value, false, description. Check to run full end-to-end tests. Choice name, DPLOSRVR choices. Server A, Server B, Server C, description. Choose which server to deploy to. Stages. Stage build, / stage run tests. When. Expression, params.runfulltsds == true. Conditional execution based on parameter. Steps. Echo running full tests. $params.runfulltsds. sh/runaltestsh. Stage deploy. Steps. Echo deploying to params target environment on params.dplosrvr. sh/deploy_upsh params target environment params.dplosrvr. When you queue a build for this pipeline, Jenkins will present a form for you to fill in these parameters. Inside your Jenkins file, you access the parameter values using the params object, e.g., params target environment. This makes a single pipeline highly reusable for different deployment scenarios without altering the underlying code. Summary: this chapter expanded your toolkit for building sophisticated Jenkins pipelines. We explored advanced agent directives for fine-grained control over execution environments, learned how to organize stages using parallel blocks for efficiency, and delved into powerful steps and directives like when for conditional execution and input for manual approvals. You also learned how to manage build outputs with archive artifacts and render test results with Junit. Finally, we covered robust error handling and notification strategies using the post section and the immense flexibility offered by parameterized builds. With these tools, you are well on your way to designing and implementing complex, resilient, and highly automated CI/CD workflows. In the next chapter, we'll look at extending Jenkins capabilities even further through its rich plugin ecosystem. Chapter 7, Extending Jenkins, Mastering Plugins and Integrations. You've now successfully set up a Jenkins instance and built your first pipeline. The power of Jenkins, however, truly comes from its vast and vibrant plugin ecosystem. While the core Jenkins engine provides the orchestration capabilities, plugins are the specialized tools that allow Jenkins to connect with virtually any other system or perform a myriad of highly specific tasks within your CI/CD workflow. This chapter will guide you through mastering Jenkins extensibility through its plugins and integrations. 7.1 The Jenkins Plugin Ecosystem Revisited. In Chapter 2, we briefly touched upon the importance of plugins. Let's reiterate why they are so fundamental to Jenkins' success. Customization. Plugins allow you to tailor Jenkins to your exact needs, integrating with your specific SCM, build tools, testing frameworks, deployment targets, and notification systems. Adaptability. The open-source nature means that as new technologies emerge, e.g., new cloud services, programming languages, or testing methodologies, the community often develops plugins to support them, keeping Jenkins relevant. Modularity. Instead of a monolithic application with every possible feature built in, Jenkins is modular. You only install the functionalities you need, keeping your instance leaner and more efficient. Community contribution. The sheer number and variety of plugins reflect the needs and contributions of a massive global community. If you have a specific integration requirement, chances are someone has already built a plugin for it. The official Jenkins website, plugins.jenkins.io, serves as the central marketplace for all available plugins, providing documentation, compatibility information, and download links. 7.2. Installing and managing plugins. Installing and managing plugins is a straightforward process handled directly within the Jenkins user interface. Accessing plugin management. From your Jenkins dashboard, navigate to Manage Jenkins in the left-hand pane. Click on Manage Plugins. Plugin tab overview. The Manage Plugins page has several tabs. Updates. Shows available updates for your currently installed plugins. It's crucial to regularly check this tab to keep your plugins secure and up to date. Available plugins. This is where you find new plugins to install. You can use the filter box to search for specific plugins. Installed plugins lists all plugins currently installed on your Jenkins instance, along with their versions. From here, you can enable, disable, uninstall if no other plugin depends on it, or check the documentation for each plugin. Advanced offers more advanced options, such as uploading a plugin manually, checking for available updates, or configuring a proxy for plugin downloads. Installing a plugin, go to the Available Plugins tab. Use the filter box to search for the plugin you need, e.g., Slack notification. Check the box next to the plugin's name. You have two options: install without restart. Jenkins will try to install the plugin on the fly. This often works, but some plugins require a restart. Download now and install after restart. The plugin will be downloaded and installed when Jenkins next restarts. This is the safest option if you're unsure. After installation, Jenkins might prompt you to restart, or it will restart automatically if you selected that option. Understanding plugin dependencies. Plugins often rely on other plugins to function correctly. When you select a plugin for installation, Jenkins will automatically identify and select any required dependencies for you. This is usually managed seamlessly, but it's good to be aware that uninstalling a plugin might affect others that depend on it. 7.3. Essential plugins for CI/CD. While thousands of plugins exist, a core set is almost universally used in CI/CD workflows. Knowing these categories will help you find what you need. Source code management, SCM integration. Git plugin, absolutely fundamental for connecting Jenkins to Git repositories, GitHub, GitLab, Bitbucket, etc. It manages pulling code, handling credentials, and triggering builds on pushes. Subversion plugin, for projects still using SVN. Build tools and environments. Maven integration plugin. Extends Jenkins to understand Maven projects, simplifying configuration for POM XML-based builds. Gradle plugin, similar integration for Gradle projects. Node.js plugin, allows Jenkins to manage and use different Node.js installations for JavaScript TypeScript projects. Testing and reporting. JUnit plugin, crucial for parsing XML test reports generated by most unit integration testing frameworks and displaying results directly in Jenkins, including trends and individual test case details. Cobertura plugin/Yako co-plugin, for reporting code coverage metrics. Sonar Quebec scanner for Jenkins, facilitates integration with Sonar Quebec for static code analysis, code quality, and security checks. Deployment and orchestration. SSH pipeline steps/SSH agent plugin, for executing commands on remote servers via SSH, often used for deployment. Docker pipeline plugin, enables interaction with Docker, allowing you to build and push Docker images and even run pipeline steps inside specified containers. Kubernetes plugin, integrates Jenkins with Kubernetes, enabling dynamic provisioning of build agents as Kubernetes pods and interaction with Kubernetes resources. CloudBees AWS pipeline/Azure/GCP plugins offer specific steps and integrations for popular cloud providers. Notification, mailer plugin, for sending email notifications about build status. Slack notification plugin, Microsoft Teams notification plugin, for sending build status updates directly to team communication channels. Authentication and authorization, LDAP plugin, for integrating with corporate LDAP or Active Directory systems for user authentication. Role-based access control, RBAC plugin, provides more granular control over user permissions, allowing you to define roles, e.g., developer, QA, release manager, and assign specific permissions to those roles. Choosing the right plugins can significantly streamline your pipeline development and provide rich insights into your software delivery process. 7.4. Integrating with external tools. Beyond simply installing plugins, effective CI/CD often relies on seamlessly connecting Jenkins with other specialized tools in your ecosystem. Source code management, SCM, platforms, GitHub, GitLab, Bitbucket, webhooks, the most efficient way to trigger Jenkins builds upon code pushes. Instead of Jenkins constantly polling the SCM is configured to send a webhook, an HTTP post request, to a specific Jenkins URL whenever a change occurs. This provides instant build feedback. You typically configure webhooks in your SCM repositories settings page, pointing to Jenkins URL/GitHub webhook/ or similar. Credentials. Using personal access tokens, PATS, or SSH keys configured within Jenkins Credentials Store is crucial for secure communication with private repositories, ensuring Jenkins can clone code without hard-coding sensitive information. Artifact management systems, Nexus Artifactory. Once your build produces an artifact, e.g., a jar file, a Docker image, you'll want to store it in a central, versioned repository. Tools like Sonatype Nexus and JFrog Artifactory are designed for this. Jenkins plugins, e.g., Artifactory plugin or Nexus Platform plugin, allow your pipelines to seamlessly publish artifacts to these repositories and resolve dependencies from them. This ensures consistency and traceability of your build outputs. Code quality analysis, Sonar Quebec. Sonar Quebec is a leading platform for continuous inspection of code quality and security. The Sonar Quebec scanner for Jenkins plugin makes it easy to integrate. Your Jenkins pipeline step would typically trigger a Sonar Quebec scan after a successful build. The plugin then processes the results, and Jenkins can display a quality gate status to indicate whether the code meets predefined quality standards, e.g., no critical bugs, high test coverage. This shift-left approach helps catch code quality issues early. Containerization technologies, Docker. Modern applications are increasingly deployed as containers. Jenkins integrates deeply with Docker. The Docker pipeline plugin enables powerful Docker DSL, domain-specific language, steps within your Jenkins file. This allows you to build Docker images, Docker build, myapp 1.0, push images to Docker registries, myImagePush, even run individual pipeline stages or steps within temporary Docker containers, ensuring a clean and consistent build environment. Cloud providers, AWS, Azure, GCP. Major cloud providers offer Jenkins plugins to facilitate deployment and management of resources directly from your pipelines. These plugins allow you to deploy applications to services like AWS EC2, Azure App Service, Google Kubernetes Engine. Provision infrastructure using cloud-specific tools directly within your pipeline steps. Manage cloud credentials securely within Jenkins. The effectiveness of your CI/CD pipeline often hinges on how well these different tools communicate and interact, with Jenkins serving as the orchestrator. 7.5. Understanding shared libraries for pipeline reusability. As your number of pipelines grows, you might notice common patterns appearing across multiple Jenkins files. This could be standard build steps, e.g., for building a Java application, deployment routines, or notification patterns. Copying and pasting this logic across many pipelines is inefficient and error-prone. This is where Jenkins shared libraries come in. A shared library allows you to define reusable pieces of pipeline code, like Groovy scripts, in a separate Git repository. These reusable components can then be called from any Jenkins file in your organization. Why use shared libraries? Dry principle, don't repeat yourself, avoids duplication of code across multiple pipelines. Standardization enforces best practices and consistent workflows across teams. Maintainability. When a common step needs an update, you change it in one place, the shared library, and all pipelines using it automatically benefit from the change. Abstraction. Developers can use high-level functions without needing to know the underlying implementation details. Basic concept. You create a Git repository, e.g., Jenkins shared libs, with a specific directory structure. Inside, you define Groovy scripts as global variables or custom steps. For example, a build Java app Groovy file might contain the Maven clean install commands. You configure Jenkins to load this shared library, manage Jenkins system, global pipeline libraries. In your Jenkins file, you can then simply call build Java app, as if it were a built-in Jenkins step. Practical application, conceptual, instead of having these steps in every Jenkins file. Stage build Java. Steps. sh mvn clean install, dalo snapshots equals true. Archive artifacts target /* jar. You could define a function in a shared library and call it like this. In your Jenkins file, assuming mylib is the name configured for your shared library. Libraries mylib. Pipeline, agent any. Stages, stage build Java app. Steps, mylib build and archive Java app, calls the reusable function. This significantly simplifies your Jenkins files and promotes proper code modularity in your CI/CD pipelines. Anecdote: I once worked on a large project where every microservice had its own Jenkins file. One day, our security team mandated a new static analysis tool that had to run on every commit. Initially, the plan was to modify hundreds of Jenkins files, which would have taken weeks and introduced potential inconsistencies. Then, our lead DevOps engineer remembered how a critical pipeline plugin allowed us to simply add a single line to a shared library function that all those Jenkins files called. With that one change in the shared library, every single microservice pipeline automatically started incorporating the new security scan. This not only saved an immense amount of time, but also ensured universal compliance instantly. It truly underscored the power of modularity and a well-designed plugin/shared library ecosystem. Summary: this chapter highlighted the indispensable role of Jenkins plugin ecosystem in extending its functionality. You learned how to install and manage plugins, explored essential plugins across various CI/CD categories, and understood how to integrate Jenkins with vital external tools like SCM platforms, artifact repositories, code quality solutions, container technologies, and cloud providers. Finally, we introduced the powerful concept of shared libraries, which enables code reusability and standardization across your pipelines. With these integration and extension capabilities, Jenkins becomes an incredibly versatile and scalable orchestrator for your entire software delivery lifecycle. In the next chapter, we'll discuss how to scale your Jenkins environment and manage its distributed build capabilities. Chapter 8: Nodes, Agents, and Scaling. Distributing your builds. As your software development grows, so does the demand on your CI/CD system. A single Jenkins instance can quickly become a bottleneck if it's responsible for building all your projects. This is where Jenkins' distributed architecture, involving nodes or agents, becomes paramount. This chapter will explain the master agent model in detail, guide you through setting up agents, and introduce strategies for scaling your Jenkins environment using cloud-based and containerized agents. 8.1 The Master Agent Architecture Explained. In Chapter 2, we briefly introduced the Jenkins Master Agent Architecture. Let's delve deeper into why this model is crucial for scaling and managing diverse build environments. Single master limitations. Initially, your single Jenkins master server handles all tasks: scheduling, managing the UI, storing configurations, and executing builds. For a small number of infrequent, lightweight jobs, this is perfectly fine. However, as your team grows, the number of projects increases and builds become more complex or frequent, the master can quickly become overloaded. Resource exhaustion. Builds consume CPU, memory, and disk I/O. If too many demanding builds run concurrently on the master, it can become slow and unresponsive. impacting UI performance, job scheduling, and overall reliability. Dependency on master. If the master machine fails or needs maintenance, all builds stop. Environmental conflicts. If different projects require different operating systems, JDK versions, or specific tools, e.g., Python 2 versus Python 3, installing everything on a single master can lead to conflicts and dependency hell. Benefits of agents nodes. By offloading the execution of most builds to separate machines called agents or nodes, Jenkins overcomes these limitations. Isolation. Each agent can be configured with a specific clean environment, operating system, and set of tools required for a particular type of build. This isolates build environments, preventing conflicts and ensuring consistency. Load distribution. Builds are distributed across multiple agents. This allows more builds to run concurrently without overwhelming any single machine, drastically improving overall build throughput. Scalability. When demand increases, you can simply add more agents to your Jenkins environment, providing more build capacity. Diverse environments. Agents can run on different operating systems, Linux, Windows, macOS, or even as Docker containers or Kubernetes pods, allowing you to run builds for various platforms. Increased resilience. If one agent fails, other agents can continue processing builds. The master, being less burdened, remains stable. The master's role then becomes primarily about orchestration, deciding which agent should run which job, collecting results, and serving the user interface. The agents are the workhorses performing the actual compilation, testing, and deployment. 8.2. Setting up Jenkins agents. Setting up Jenkins agents involves bringing new machines online and connecting them to your Jenkins master. There are several ways to launch agents, each suitable for different scenarios. Common launch methods. Launch agent by connecting it to the controller, JNLP/WebSocket. This is a very common method, especially for agents that might be behind a firewall or in a network segment where the master can't initiate an SSH connection directly. The agent machine runs a small Java executable, a client, that initiates a connection out to the Jenkins master. Configuration in Jenkins. On the Jenkins master, go to Manage Jenkins Nodes New Node. Give it a name, e.g. Linux Build Agent 01, mark it as Permanent Agent, and click Create. On the configuration page, you'll specify Remote Root Directory, the workspace on the agent where jobs will run, e.g. home/Jenkins/workspace. Host key verification strategy. For SSH-based connections, how strictly to verify the agent's identity. Launch method. Select Launch Agent by connecting it to the controller. Credentials. If the agent needs specific credentials to connect, you can configure them here. Executing on agent. Jenkins will then provide a command you need to run on the agent machine, e.g. java jar agent jar JNLP URL HTTP //jenkinsurl/computer/agent name /Jenkins agent JNLP secret. This command downloads the Jenkins agent client and connects it to the master. Pros: works well with agents behind NAT firewalls. The agent initiates the connection. Cons: requires manual setup on each agent or a scripting solution. Launch agent via SSH for Linux Mac OS. This is a popular and straightforward method for Linux and Mac OS agents where the Jenkins master has SSH access to the agent machines. Prerequisites: SSH server running on the agent, SSH client on the Jenkins master, and a user account on the agent that Jenkins can log in as, usually a dedicated Jenkins user. Credentials. You'll typically set up SSH credentials, username and private key, in Jenkins credentials store, which the master will use to log into the agent. Configuration in Jenkins. Similar to JNLP, you create a new node, but select Launch Agent via SSH as the launch method. You'll specify the agent's hostname/IP, the SSH credentials, and the remote root directory. Pros: secure and widely used. Easy to manage SSH keys. Cons: requires direct network accessibility. Firewall rules might be needed from master to agent on SSH port 22. Launch agent by executing command on master. This method is primarily used in advanced scenarios or when an external script is responsible for launching and managing agents. Jenkins simply executes a command on the master that, in turn, brings the agent online. Not typically used for beginners. Agent configuration details. Regardless of the launch method, you'll configure some common settings for each agent. Name, a unique identifier for the agent, e.g., Linux Java 11 Builder. Description, a descriptive text explaining the agent's purpose. Number of executors, how many concurrent builds this agent can run. A typical value is 1 or 2, depending on the agent's resources. Remote root directory, the path on the agent where Jenkins will create workspaces for jobs. Labels, 1 or more labels, e.g. Linux, Java 11, fast.io. Labels are crucial for directing jobs to specific agents. A job's agent label. Directive in the Jenkins file, as seen in Chapter 6, uses these labels to select an appropriate agent. Usage, use this node as much as possible. Jenkins will use this agent for any job where its label matches. Only build jobs with label expressions matching this node. This turns the agent into a dedicated resource for jobs explicitly requesting its labels. Practical application. Setting up a Linux agent via SSH. On the agent machine, e.g., a new Linux VM. Install Java, if not already present. Sudo apt update, and in sudo apt install OpenJDK headless. Create a user for Jenkins, e.g. Jenkins. Sudo userad, msbin bash Jenkins. Configure SSH for that user. Generate an SSH key pair on your Jenkins master for the Jenkins user, and copy the public key ~SSH/idisapub to the agent's Jenkins. /authorized keys file. Ensure correct permissions. Verify SSH access from master. From your Jenkins master, try SSH Jenkins agent IP. On the Jenkins master, go to Manage Jenkins Credentials System, Global Credentials, Add Credentials. Choose SSH username with private key. Set scope to global. Enter username as Jenkins. For private key, select Enter directly and paste the private key you generated on the master machine. Give it a descriptive ID, e.g. Jenkins agent SSH key. Save. Go to Manage Jenkins node's new node. Enter node name, e.g. My Linux agent. Select Permanent Agent. Click Create. Configure the node. Description, dedicated agent for Linux builds. Number of executors, 2 for 2 concurrent builds. Remote root directory, home/Jenkins/workspace. Labels, Linux Java 11. Launch method, launch agent via SSH. Host, IP address of your agent machine. Credentials, select the SSH credential you just created, Jenkins agent SSH key. Host key verification strategy. Non-verifying verification strategy, for quick setup, but use known hosts file verification strategy for production. Click Save. Jenkins should now attempt to connect to your agent. If successful, its status will turn green in the nodes list. 8.3 Managing Agent Resources. Once you have agents connected, keeping them healthy and ensuring optimal resource utilization is important. Concurrency control, number of executors. Each agent configuration has number of executors. This limits how many concurrent builds can run on that specific agent. Set this value based on the agent's CPU, RAM, and disk I/O capabilities. Over-provisioning can lead to slow builds due to resource contention. Under-provisioning means some capacity sits idle. Keeping agents online. For permanent agents, ensure they are configured to start automatically on system boot. For SSH agents, the master will attempt to reconnect if SSH drops. For JNLP agents, the Java client needs to be kept running as a service on the agent machine. Monitoring agent status. In Manage Jenkins nodes, you can see the status of all your agents. A red X indicates a disconnected agent, while a green checkmark means it's online and ready to accept builds. You can also view logs for agent connections and disconnections. 8.4 Scaling Jenkins with cloud agents. For highly dynamic workloads, where demand for build capacity fluctuates, manually managing static agents becomes tedious and inefficient. Cloud agents provide an elegant solution by dynamically provisioning and deprovisioning build machines on demand. Why use cloud agents? On-demand capacity. Spin up agents only when needed, minimizing idle infrastructure costs. Cost efficiency. Pay only for the compute resources when they are actively being used for builds, pay as you go. Ephemeral environments. Each build can get a fresh, clean environment, eliminating pollution from previous builds. Elasticity. Automatically scales up the number of agents during peak demand and scales down during low periods. Integration with cloud providers. Jenkins has plugins for all major cloud providers, e.g., Amazon EC2 plugin, Azure VM Agents plugin, Google Compute Engine plugin. These plugins allow Jenkins to interact with the cloud provider's API to create a virtual machine, VM, instance from a predefined image, which has Java and SSH configured. Connect to that VM as a Jenkins agent. Run the build. Terminate the VM instance once the build or a period of inactivity is complete. Practical application, conceptual, how a cloud agent works. A build is triggered and no suitable agent is immediately available. Jenkins, via the cloud plugin, requests a new VM instance from AWS EC2. Oz provisions the VM from a golden image. The Jenkins EC2 plugin communicates with the newly launched VM, usually via SSH, to install the necessary agent software and connect it to the Jenkins master. The build runs on this new, ephemeral agent. After the build finishes and a configurable idle timeout expires, Jenkins instructs the cloud provider to terminate the VM. This model is transformative for cost efficiency and scalability, making your CI/CD infrastructure highly responsive to actual demand. 8.5. Containerizing Jenkins agents with Docker. Even without a full-blown cloud integration, Docker can significantly enhance your agent strategy, bringing benefits of consistency and portability. Benefits of Docker agents. Consistency. Define your build environment, OS, JDK, tools in a Docker file. Every time an agent container is spun up, it's identical, ensuring consistent and reproducible builds. Portability. The Docker image can be run on any host with Docker installed, simplifying agent provisioning. Rapid provisioning. Containers start extremely quickly compared to VMS, leading to faster agent availability. Clean slate. Each build can run in a fresh container, eliminating side effects from previous builds. Using Docker agents within pipelines, agent Docker. This is one of the most powerful uses of Docker with Jenkins. Instead of attaching a separate permanent agent to Jenkins, you can instruct your pipeline itself to use Docker to run its steps. Pipeline, agent, Docker, image Maven 3.8.5 JDK 11. Use this Docker image for the agent. argsv/tmp/m2/root/m2 mount host maven cache. Stages. Stage build and test. Steps. sh mvn clean install. When this pipeline runs, Jenkins will pull the Maven 3.8.5 JDK 11 Docker image, if not already present. Start a new container from that image. Mount the project's workspace volume into the container. Execute all steps within the build and test stage inside that container. Once the stage is complete, the container is stopped and removed, leaving a clean environment. This means your Jenkins master only needs Docker installed. It doesn't need all your project's various SDKs or build tools directly on its file system. 8.6. Orchestrating builds with Kubernetes, Jenkins on Kubernetes. The ultimate in dynamic, scalable, and resilient build environments is to run Jenkins agents directly on a Kubernetes cluster. While a deep dive into Kubernetes is beyond the scope of this book, understanding its relationship with Jenkins for scaling is important. Brief introduction to Kubernetes. Kubernetes is an open-source container orchestration platform for automating deployment, scaling, and management of containerized applications. It provides an efficient way to manage resources in a cluster. How Jenkins leverages Kubernetes for dynamic agent provisioning. The Jenkins Kubernetes plugin allows Jenkins to dynamically provision Kubernetes pods, the smallest deployable units in Kubernetes, containing one or more containers, to act as temporary Jenkins agents. When a build is queued and no suitable agent is available, Jenkins tells the Kubernetes plugin to create a new pod in the Kubernetes cluster. This pod is specifically designed to be a Jenkins agent, containing necessary tools like Java and any specific build environments, e.g., a Maven container, a Node.js container. Once the pod is ready, Jenkins connects to it and executes the build steps within the pod's containers. After the build completes, the pod is automatically terminated and cleaned up from the Kubernetes cluster. Running pipelines in Kubernetes pods, conceptual. This approach provides extreme elasticity. Kubernetes can quickly scale the number of build agent pods up and down based on demand, sharing common cluster resources efficiently. Resource efficiency. Agents only consume resources while actively running builds. Reliability. Kubernetes handles self-healing of the cluster, ensuring agents are always available. Isolated environments. Each build runs in its own dedicated pod, providing complete isolation. This setup enables a highly scalable, resilient, and resource-efficient CI/CD infrastructure, especially for organizations heavily invested in cloud-native technologies. Summary: this chapter expanded on the foundational master agent architecture, explaining how it enables Jenkins to distribute workloads, isolate environments, and scale efficiently. We walked through common methods for setting up permanent agents via SSH or JNLP. More importantly, we introduced advanced strategies for truly scaling your Jenkins environment, leveraging the elasticity and cost-effectiveness of cloud-based agents and the consistency and portability of containerized agents using Docker. Finally, we touched upon the most advanced form of scaling, by integrating Jenkins agents directly with Kubernetes for ultimate dynamic provisioning. With these concepts, you are now equipped to design a Jenkins infrastructure that can handle the growing demands of your software development efforts. In the next chapter, we will shift our focus to an equally critical topic: securing your Jenkins environment and implementing best practices. Chapter 9, Security and Best Practices, Protecting Your Jenkins Environment. You've now learned how to set up, build pipelines, extend with plugins, and scale Jenkins. However, none of this matters if your Jenkins instance is compromised. As an automation server that connects to your source code, runs your tests, and especially deploys your applications, Jenkins stores and accesses highly sensitive information. Source code, credentials for external systems, databases, cloud providers, APIs, and access to production environments. Securing Jenkins is not an afterthought, it's a critical, ongoing responsibility. This chapter will guide you through essential security measures and best practices for protecting your Jenkins environment. 9.1. The importance of Jenkins security. A compromised Jenkins instance can have catastrophic consequences. Data breach. Access to your source code means potential exposure of intellectual property, proprietary algorithms, or sensitive customer data. Malicious code injection. An attacker could inject malicious code into your build pipelines, leading to corrupted applications, backdoors, or even ransomware deployment in your production environments. Unauthorized deployments. Attackers could use your Jenkins instance's credentials to deploy their own malicious applications, wipe out data, or cause significant disruption to your services. Lateral movement. Jenkins, with its broad network access and credentials, can be a pivot point for attackers to move deeper into your corporate network. Reputational damage. A security incident stemming from your CI/CD system can severely damage your organization's reputation and customer trust. Given these risks, securing Jenkins must be treated with the same rigor as securing your production servers. 9.2. Authentication. Who can access Jenkins? Authentication is the process of verifying a user's identity. Jenkins offers several ways to authenticate users. Configuring this is the first step in protecting your instance from unauthorized access. Security realm. This setting defines how Jenkins verifies user identities. You can find this under Manage Jenkins, Configure Global Security realm. Jenkins' own user database. This is the default. Users are created directly within Jenkins, and their credentials are managed there. Suitable for small teams but lacks centralized management. LDAP Active Directory, recommended for most organizations. Jenkins integrates with your existing corporate directory, like Microsoft Active Directory or OpenLDAP. Users authenticate with their corporate usernames and passwords, simplifying user management and enforcing corporate password policies. SAML/OAuth for integration with single sign-on, SSO, providers like Okta, Auth0, Google, GitHub, or GitLab. This streamlines login for users and centralizes identity management. Delegated authentication to Apache/Nginx. If Jenkins is behind a reverse proxy, like Nginx or Apache, that handles authentication, Jenkins can trust that authentication. Practical application. Enabling basic user authentication. If not using LDAP SSO, navigate to Manage Jenkins, configure global security. In the Security Realm section, select Jenkins' own user database. Check Allow users to sign up, only temporarily if you want users to create their own accounts. Then uncheck it once all legitimate users have signed up. It's generally better for an administrator to create accounts manually. In the Authorization section, discuss next, make sure matrix-based security or role-based strategy is selected to fine-tune permissions. Save your changes. You will likely be prompted to log in with the admin account you created during initial setup. 9.3 Authorization. What can they do? Authorization determines what an authenticated user is allowed to do within Jenkins. It's about granular access control, ensuring users only have the minimum necessary permissions, principle of least privilege. Authorization strategy. This setting defines how permissions are managed. Found under Manage Jenkins, configure global security authorization. Anyone can do anything, legacy mode, dangerous, should never be used in a production environment. Anyone can access and modify anything. Logged-in users can do anything. Slightly better, but still allows any authenticated user, even non-admin, to delete jobs, change global settings, etc. Not recommended. Matrix-based security. Provides fine-grained control. You define users' groups and then grant specific permissions, read, write, delete, configure, run, etc., at a global level and/or for individual jobs. It can become complex to manage for many users or jobs. Role-based access control, RBAC, plugin, the recommended authorization strategy for medium to large teams. You define roles, e.g., developer, QA lead, release manager, with specific permissions. Then, users or groups are assigned these roles. This simplifies management since you change a role's permissions, and all users in that role inherit the changes. This is managed through the Manage Jenkins Manage and Assign Roles section after installing the plugin. Practical application. Using role-based access control requires plugin installation. Install the Role-Based Access Control plugin via Manage Jenkins plugins. Go to Manage Jenkins, configure global security. Under Authorization, select Role-Based Strategy. Save. You may be redirected to the Roles Management page. Manage and assign roles. Manage roles. Create global roles. Define roles like admin all permissions, developer read access, build jobs, but not configure delete sensitive system settings, viewer read-only access. Create item roles for jobs. Define roles like job admin, job builder, job viewer, and assign specific permissions related to jobs, e.g., build, configure, delete. You can use regular expressions here, e.g., my project, for projects prefixed with my project. Assign roles. Map users' groups from your security realm to the roles you've created. 9.4 Managing credentials securely. Hard-coding passwords or sensitive tokens directly in your Jenkins files or job configurations is a major security risk. Jenkins provides a dedicated system for securely storing and managing credentials. The Jenkins Credentials plugin. This core plugin allows you to store various types of credentials, username with password, for Git, external APIs, etc. SSH username with private key, for connecting to SSH agents, Git repositories via SSH. Secret text, for API keys, tokens, or other sensitive strings. Secret file, for entire files containing sensitive data, e.g., Kubernetes config files. Using credentials in pipelines with credentials. Once stored in Jenkins, credentials should be injected into your pipeline only when and where they are needed, using the with credentials step. This ensures that the sensitive information is not exposed in the build logs. Pipeline. Agent any. Stages. Stage deploy to API. Steps. With credentials, username password, credentials ID. My API credentials, username variable. API USER password variable. API TOKEN. SH curl U API user. $API token. https api.example.com/deploy. Credentials ID. The ID you gave the credential in Jenkins. Username variable, password variable. The environment variables that will be set within the with credentials block containing the username and password. These variables are not available outside the block. Best practice: never hardcode. Avoid plain text passwords, API keys, or secret tokens in Jenkins files, job configurations, or environment variables in global configs. Store in Credentials Manager. Use Jenkins' built-in Credentials Manager for all sensitive data. Least privilege. Configure credentials with just enough permissions for the task. Rotate regularly. Change credentials periodically. 9.5. Protecting pipeline scripts. Pipeline scripts your Jenkins files often run arbitrary code, making them a potential attack vector. Groovy Sandbox. By default, Jenkins pipelines run within a Groovy Sandbox. This is a security feature that restricts what a pipeline script can do, preventing it from accessing sensitive system resources, writing to arbitrary files, or executing harmful commands. If a script tries to call a method that is not whitelisted by the sandbox, it will be flagged as unsafe and require explicit administrator approval. Best practices: keep the Groovy Sandbox enabled, it's on by default. Only approve unsafe methods if you understand their implications and trust the source of the pipeline script. Educate your developers on writing safe pipeline code that avoids requiring sandbox approvals. Sign pipelines. For even higher security, you can configure Jenkins to only run pipeline scripts that have been digitally signed by an authorized key. This ensures code integrity and provenance. This is an advanced feature, usually reserved for very high security environments. 9.6. Securing Jenkins master and agents. Beyond the Jenkins application itself, the underlying infrastructure needs to be secured. Firewall rules. Master. Only expose necessary ports, e.g., 8080 or 443 if you're using a reverse proxy, to the internet or your internal network. Restrict access to specific IP ranges if possible. Agents. Agents typically only need to connect out to the master's JNLP port, default 50,000, if using the JNLP launch method, or the master needs to SSH into asterisk them, port 22 for SSH launch. Apply principle of least privilege to firewall rules between master and agents. Principle of least privilege for Jenkins user. The operating system user account under which Jenkins runs, both master and agents, should have the absolute minimum necessary permissions. It should not run as root, Linux, or administrator Windows. Its directories and files should have appropriate permissions. Regular security updates. Jenkins core. Keep your Jenkins master updated to the latest stable LTS releases. Updates often include critical security fixes. Plugins. Regularly update your installed plugins via Manage Jenkins Plugins Updates. Many security vulnerabilities are found in plugins. Operating system. Ensure the underlying OS for both master and agents is kept up to date with security patches. JDK. Keep the JDK used by Jenkins and your build tools updated. Audit trails. Regularly review Jenkins build logs, system logs, and security logs for suspicious activity. Integrating Jenkins logs with a centralized security information and event management (SIEM) system can be beneficial for larger organizations. 9.7. Other security best practices. HTTPS setup. Always put Jenkins behind a reverse proxy, like Nginx or Apache, and force HTTPS for all web traffic. This encrypts communication between users and Jenkins, and between Jenkins and its agents. Regular backups. Implement a robust backup strategy for your Jenkins home directory. This contains all your job configurations, build history, plugins, and user data. In case of a compromise or system failure, you can quickly restore. Disable unnecessary services. Turn off any Jenkins features or plugins that you don't actively use to reduce the attack surface. Security scans. Periodically run vulnerability scanners against your Jenkins instance and the underlying server. Dedicated build user. In external systems, e.g., GitHub, cloud providers, use dedicated service accounts or API keys for Jenkins integrations, rather than sharing personal accounts. These should have the minimum necessary permissions. Shared libraries security. If you use shared libraries, ensure they are also managed securely, possibly in a separate, more tightly controlled Git repository. Securing Jenkins is an ongoing commitment. By implementing these measures, you significantly reduce the risk of your CI/CD system becoming a weak link in your software supply chain. Summary: this chapter underscored the critical importance of security for your Jenkins environment, outlining the severe risks of a compromised instance. We covered fundamental security measures, starting with authentication, who can access Jenkins, and authorization, what they can do, recommending solutions like LDAP SAML and role-based access control. Crucially, we detailed how to securely manage credentials using Jenkins' built-in store and the with credentials step in pipelines, emphasizing the never hardcode rule. We also discussed protecting pipeline scripts with the Groovy sandbox and securing the underlying master and agent infrastructure through firewalls, least privilege, and regular updates. Finally, we provided a list of general security best practices, including HTTPS, regular backups, and disabling unused features. By diligently applying these principles, you can transform Jenkins into a secure and trustworthy core of your automated software delivery pipeline. The next chapter will focus on keeping this critical system healthy through effective monitoring, maintenance, and troubleshooting. Chapter 10: Monitoring, Maintenance, and Troubleshooting. Keeping Jenkins healthy. Jenkins is the central nervous system for your CI/CD processes. Like any critical system, it requires regular monitoring, proactive maintenance, and effective troubleshooting strategies to ensure its continuous health, performance, and reliability. This chapter will equip you with the knowledge and tools to keep your Jenkins instance running smoothly, preventing issues before they arise and efficiently resolving them when they do. 10.1 Monitoring Jenkins health. Effective monitoring provides early warnings, helps diagnose issues, and offers insights into system performance and resource utilization. Jenkins provides built-in metrics and integrates with external monitoring solutions. Built-in metrics. Jenkins itself exposes various metrics that give you a snapshot of its health. Dashboard overview. The main Jenkins dashboard status page provides immediate visual cues. Build queue. How many builds are waiting to be executed? A consistently long queue indicates insufficient capacity. Executor usage. Shows how many of your configured build executors on master and agents are currently busy. System load. A graph of the server's CPU load. High load consistently suggests an overloaded master. Manage Jenkins system information. This page, System Info, provides detailed technical information about your Jenkins environment, including Java version, operating system, environment variables, installed plugins, and their versions. Useful for diagnostics. Manage Jenkins, manage nodes and clouds. As seen in Chapter 8, shows the status of all your connected agents, online, offline, free space, response time, plugin-based monitoring. For more granular insights, several Jenkins plugins enhance monitoring capabilities. Monitoring plugin provides a dedicated monitoring page with graphs and statistics for CPU, memory, HTTP requests, and more. It offers a more visual and historical view of Jenkins performance. Metrics plugin exposes various internal Jenkins metrics through a REST API endpoint, often metrics, which can then be scraped by external monitoring systems. External monitoring tools integration, conceptual. For production-grade Jenkins deployments, integrating with external monitoring solutions is highly recommended. Prometheus and Grafana. Prometheus is a popular open-source monitoring system that collects metrics via HTTP poll. The Jenkins Metrics plugin, as mentioned, can expose metrics in a Prometheus-compatible format. Grafana is then used to create powerful dashboards for visualizing this time series data. This allows for historical performance analysis, custom alerts, and detailed drill downs. Other APM tools. Tools like Datadog, New Relic, or Dynatrace also offer integrations to monitor JVM applications like Jenkins, providing deep insights into performance bottlenecks. Setting up alerts for critical events. Beyond just collecting metrics, you need to be notified when something goes wrong. Configure alerts in your monitoring system, e.g., Prometheus Alert Manager, or directly in Grafana for conditions like high master CPU memory usage, disconnected agents, persistent build failures, e.g., more than 5 consecutive failures for a critical job, long build queue, disk space running low. 10.2 Routine maintenance tasks. Proactive maintenance prevents most problems before they become critical. Schedule these tasks regularly to keep your Jenkins healthy. Disk space management. One of the most common issues in a busy Jenkins instance is running out of disk space. Builds generate temporary files, and artifacts accumulate over time. Build discarder strategy. For each job in its configuration, you can set a discard old builds strategy. You can opt to discard builds older than a certain number of days, e.g., 30 days. Discard old builds, keeping only a certain number of recent builds, e.g., keep only last 10 successful builds. You can also specify how many artifacts to keep. Important. Apply this to all your jobs, especially those that run frequently or produce large artifacts. Keep builds that generate production releases, of course. Workspace cleanup. Jenkins creates a workspace for each build on the agent. Ensure these are cleaned up. Most SCM plugins have an option to delete the workspace before checkout. Periodically manually clean up old or large workspaces for jobs that don't auto-clean. Snapshot/Chake management. If using Maven/Gradle, ensure your M2 or Gradle caches are configured to periodically clean up older versions or manage them at the system level. Backup and restore. Your Jenkins directory, e.g., /var/lib/Jenkins on Linux, contains all your Jenkins data, job configurations, build history, plugins, user data, secrets, etc. Losing this is catastrophic. Regular backups. Implement a daily or even more frequent backup of your Jenkins directory. This can be done via manual copy. Simply copying the directory requires stopping Jenkins. Backup plugin. The Thin Backup or Backup plugin can create compressed backups of your configuration files, though not necessarily large artifacts. Native OS backup tools use tools like rsync, Linux, or Windows Backup. Managed services. If running on cloud VMS, leverage snapshot capabilities. Off-site storage. Store backups off-site or in cloud storage for disaster recovery. Restore drills. Periodically test your restore process to ensure backups are valid and you can recover quickly. Upgrading Jenkins and plugins. Keeping Jenkins and its plugins up to date is crucial for security, performance, and new features. LTS releases. Stick to long-term support, LTS, releases for the Jenkins core, as they are more stable and receive regular bug and security fixes. Upgrade the core every few months. Plugin updates. Regularly check manage Jenkins plugins, updates, and install them. Staging environment. For production Jenkins instances, always test major Jenkins core and critical plugin upgrades in a staging environment that mirrors your production setup first. This helps identify breaking changes or incompatibilities before affecting your critical builds. Rolling back. Be prepared to roll back. Before a major upgrade, take a full backup. Know how to revert to a previous Jenkins version or particular plugin version if issues arise. Periodic plugin reviews. Over time, you might install plugins you no longer need. Review your installed plugins periodically. Manage Jenkins plugins, installed plugins. Disable or uninstall unused plugins to reduce complexity, potential security vulnerabilities, and resource consumption. 10.3 Common Jenkins problems and solutions. Despite proactive measures, issues can arise. Knowing how to diagnose and approach common problems will save you significant time. Build failures. Symptom. Jobs turn red or yellow unstable. Diagnosis. Always start by checking the console output for the failed build. It will usually contain error messages, stack traces, or command output indicating what went wrong, e.g., compilation errors, test failures, missing dependencies. Solutions: read the error messages carefully. Check for changes in the source code or build script. Verify the build environment on the agent, JDK version, tool paths. Ensure all necessary services, databases, APIs are running if the build depends on them. Agent connectivity issues. Symptom: agents appear offline in managed Jenkins nodes or builds queue up waiting for an agent. Diagnosis: check the agent's machine itself. Is it powered on? Is Java running? Check network connectivity between master and agent ping, telnet to port 22 for SSH or 50,000 for JNLP. Check firewall rules on both master and agent. Review the Jenkins master's logs for agent connection errors. For SSH agents, verify SSH credentials and ensure the agent's SSH service is running. Solutions: restart the agent service machine. Reconfigure credentials if they've changed. Adjust firewall rules. Pending builds, long queue. Symptom: many builds are stuck in the build queue, not starting. Diagnosis: check manage Jenkins nodes. How many agents are online? How many executors are free? Are jobs requesting specific labels that are currently unavailable due to agent offline or all busy? Are there too many jobs running concurrently for the available executor capacity? Solutions: add more agents. Increase the number of executors on existing agents if resources allow. Optimize job execution times. Review job queuing strategies or set concurrency limits on specific jobs. Performance issues: slow UI builds. Symptom: Jenkins UI is slow or builds take an unusually long time. Diagnosis: monitor master CPU memory in managed Jenkins monitoring or external tools. Check if the master is running builds directly. It shouldn't be for heavy workloads. Look for plugin issues. A misbehaving plugin can consume excessive resources. Disk I/O bottlenecks. Solutions: move all builds to agents. Increase master resources, CPU, RAM. Upgrade hardware VM specs. Review and disable unnecessary plugins. Optimize disk I/O, e.g., faster storage, separate disk for workspaces. Pipeline syntax errors. Symptom: pipeline does not start or fails early with a syntax error. Diagnosis: the console output will typically point to the line number and type of error. Use the pipeline syntax snippet generator, your Jenkins URL /pipeline syntax / to generate correct syntax for various steps. Use the declarative pipeline linter, your Jenkins URL /pipeline model converter / to validate your Jenkins file without running it. It catches common syntax errors. Solutions: correct the Jenkins file syntax based on the error message or linter output. 10.4 Effective troubleshooting techniques. Beyond specific solutions, adopting a systematic approach to troubleshooting is vital. Check logs first. This is paramount. Jenkins logs, master and agent, system logs, dmesc, /var/log/syslog on Linux, and specific application logs related to your build, e.g. Maven logs, often contain key diagnostic information. Isolate the problem. Is it specific to one job or all jobs? Is it specific to one agent or all agents? Did it start after a recent change, Jenkins upgrade, plugin install, code change? Can you reproduce the issue? If so, try to simplify the scenario. Divide and conquer. Break down complex CI/CD pipelines into smaller, simpler stages or steps. Test them individually to pinpoint the failure point. Check network, DNS, firewalls. Many problems stem from connectivity issues that might not be immediately obvious. Leverage community resources, Jenkins documentation. The official Jenkins documentation and wiki are excellent resources. Stack Overflow. A vast community, many Jenkins-related questions have already been answered. Jenkins Community Forum, a dedicated place to ask questions and get help. Plugin documentation. Each plugin usually has its own documentation on the Jenkins website. Anecdote: I remember one particularly frustrating intermittent build failure. The build would pass 9 out of 10 times, but occasionally fail without a clear error in the console output. We pored over the Jenkins logs, checked the agent's health. Everything seemed fine. It turned out, after hours of head scratching, that a very specific test case, which involved making an external API call, was occasionally hitting a rate limit on the API provider's side. The error wasn't being properly reported back to Jenkins console. By setting up very detailed logging in our application's test code itself, we finally caught the intermittent failure. The lesson: sometimes the problem isn't with Jenkins, but with the application or its external dependencies. You have to look beyond Jenkins' perspective. 10.5 High Availability Considerations, briefly. For mission-critical production environments, ensuring Jenkins is highly available, means designing it to avoid single points of failure. While setting up Jenkins is complex and often involves specialized solutions, it typically means shared storage for Jenkins. The Jenkins directory is stored on a distributed file system like NFS, GlusterFS, or cloud-native shared storage, accessible by multiple potential Jenkins master instances. External database for configurations. Instead of storing configurations directly on the file system, Jenkins can be configured to store them in an external, highly available database. Load balancer. A load balancer distributes traffic between active and passive Jenkins master instances. Active-passive setup. One master is active, processing requests, while another is passive, ready to take over if the active one fails. Specialized plugins/distributions. Solutions like CloudBees Jenkins Enterprise, a commercial distribution, or custom Kubernetes deployments offer out-of-the-box features. For most users starting their Jenkins journey, a single, well-maintained instance with regular backups is sufficient. Becomes a consideration as your reliance on Jenkins becomes absolute for your business. Summary: keeping your Jenkins environment healthy is an ongoing effort that requires diligence. This chapter equipped you with techniques for monitoring its well-being using built-in features, plugins, and external tools, along with setting up critical alerts. We emphasize the importance of routine maintenance tasks like disk space management, robust backup restore procedures, and timely upgrades. Finally, we provided a practical guide to troubleshooting common Jenkins problems, advocating for a systematic approach and highlighting the power of logs and community resources. By integrating these practices into your regular operational routine, you'll ensure your Jenkins instance remains a reliable and high-performing engine for your CI/CD pipelines. In the next chapter, we'll dive into real-world applications, showcasing how complex CI/CD patterns are implemented using Jenkins. Chapter 11, Real-World Applications, Case Studies, and Advanced CI/CD Patterns. In the preceding chapters, we've built a strong foundation, covering Jenkins installation, job configuration, and sophisticated pipeline design using declarative syntax. Now, it's time to see how these concepts translate into practical, real-world CI/CD scenarios. This chapter will explore various case studies, demonstrating how Jenkins orchestrates complex software delivery workflows and enables advanced deployment patterns. While we won't present full code listings, we'll outline the conceptual flow and highlight key Jenkins features used. 11.1 Case Study 1. Web Application Deployment Pipeline, Traditional VM on-premise. Let's consider a common scenario. A Java web application, e.g., a Spring Boot application that needs to be built, tested, and deployed to various environments running on traditional virtual machines or on-premise servers. Scenario: application, Java Spring Boot REST API, version control, Git GitHub, build tool, Maven, deployment target, Linux VMS Dev QA production, database, external migrated separately or through applications migration scripts. Conceptual Jenkins pipeline, Jenkins file flow. Conceptual Jenkins file for Java web app deployment. Pipeline, agent label Linux. Run on a Linux agent with Java and Maven. Stages, stage pull request check, only for PRS. Quick checks, when changelog, runs for PRS pseudocode. Actual logic more complex. Steps, echo running fast checks for pull request. SHMVN compile dskip tests, fast compile check. SHMVN test, quick unit tests. Stage build and package. When branch develop, branch main, only for main development branches. Steps, echo building and packaging the application. SHMVN clean install dskip tests, build jar war. Archive artifacts. Target jar, fingerprint. True. Stage, run integration tests. When branch develop, branch main. Steps. Echo, setting up environment, and running integration tests. Assumes external test environment setup, or internal orchestration. sh/scripts/start test dependencies sh. Start in memory DB or test containers. mvn failsafe, integration test. Execute integration tests. Junit/target/surefire report/ XML, publish test results. Stage, code quality scan. When branch develop, branch main. Steps. Echo, executing Sonar Quebe analysis. With Sonar Quebe env, my Sonar Quebe server. Assumes Sonar Quebe scanner plugin config. mvn org sonar source scanner maven. Sonar maven plugin sonar. Stage, deploy to dev. When branch develop, automatic deployment to dev on every develop branch push. Steps. Echo, deploying to development environment. Example, SSH to dev VM to copy artifact and restart service. SHSCP target jar user at dev server, /opt/app/myappjar. SSH user at dev server, system tool restart my app service. Stage, deploy to QA. When branch main, only main branch goes to QA. This could be triggered manually after deploy to dev has been tested. Steps. Input message. Approve deployment to QA, OK. Deploy to QA. Echo, deploying to QA environment. Similar SSH SCP, steps to QA server. SHSCP target jar user at CA server, /opt/app/myappjar. SSH user at CA server, system tool restart my app service. Stage, deploy to production. When branch main, only main branch can go to production. Parameters. String name. RELEASEVRSION, default value, description. Specify the version to release. Steps. Input message. Approve production deployment for version, params release version. OK. Deploy to production. Echo, deploying version, params release version to production. SSH SCP, plus potentially more sophisticated blue-green or canary deployment logic. SHSCP target jar user at prod server, /opt/app/myappjar. SSH user at prod server, system tool restart my app service. Post-deployment smoke tests or health checks. curl fhttp //prod server /health. Echo, prod health check failed. Exit 1. Post. Always. Clean workspace on agent. Clean WS. Success. Notify team on Slack. Slack send channel, hash releases message. Deployment of env-jobname to current build current result, environment successful. Failure. Send email to responsible team. Email ext to devteam@example.com. Subject, env-jobname build failed. Body, build env-buldnumbr failed. Check console output, env-buld URL. Key takeaways from case study 1, branch-based flow. Different stages, e.g., deploy to dev, QA, prod, are executed based on the branch being built, enabling parallel development and controlled releases. Artifact management. The archive artifacts step saves the build output, ensuring the exact same artifact that passed tests is deployed. External tool integration. Demonstrates integration with Maven, Sonar Quebe, SSH, for deployment and notification services. Manual gate. The input step creates a manual approval gate before deploying to critical environments, QA, production, providing human oversight. Parameterized deployment. The deploy to production stage uses a parameter to allow specifying the release version, enabling controlled releases. Post-build actions. Notifications and workspace cleanup ensure teams are informed and the build environment stays tidy. 11.2 Case Study 2. Containerized microservice CI/CD, Docker, and Kubernetes. Modern applications often leverage microservices architecture and containerization Docker, with orchestration platforms like Kubernetes. Jenkins integrates powerfully with these technologies. Scenario, application, Node.js microservice, version control, GitLab, runtime, Docker container, orchestration, Kubernetes, deployment, dev and production Kubernetes clusters, conceptual Jenkins pipeline, Jenkins file flow, conceptual Jenkins file for containerized microservice deployment, pipeline, Agent. Docker, run pipeline, steps inside a Docker client container. Image Docker, 19.03.13. A Docker client image. args v/var/run/docker sock. /var/run/docker sock. Mount Docker daemon socket. Environment, define dynamic environment variables. dockerregistry equals your .docker.registry.com. IMAGNAMI. $Docker registry / my noded zap $n build number. kubrnetsdvc1txt equals my dev cluster. kubrnetsbrodcu1txt equals my prod cluster. Stages. Stage build Docker image. Steps. Echo building Docker image. sh Docker build t IMAGNAMI. Stage push Docker image. Steps. Echo pushing Docker image to registry. With credentials, username password, credentials ID. Docker registry creds, username variable. dockerusr password variable. dockerpss. sh Docker login u dockerusr. p dockerpss. dockerregistry. sh Docker push, IMAGNAMI. sh Docker logout, dockerregistry. Stage, run container security scan. Assuming a tool like Claire, Trivy, or Snike integrated outside or via plugin. Steps. Echo, running security scan on Docker image. sh Trivy severity high ignore unfixed, IMAGNAMI. Echo, vulnerabilities found. Exit 1. Stage, deploy to dev Kubernetes. Automatic deployment to dev cluster on every push to develop, or main. When branch develop, branch main. Steps. Echo, deploying to dev Kubernetes cluster. With kubeconfig, credentials ID. Dev kubeconfig creds, context name. kubrnetsdvc1txt. Assumes Kubernetes plugin config. sh kubectl apply fk8/dev deployment YAML. Apply k8's deployment. sh kubectl set image deployment /noded zap equals $image name. End default. Update image. sh kubectl rollout status deployment /noded zap. End default. Wait for rollout. Echo app deployed to dev at kubectl get svc noded zap o-json path equals status load balancer ingress 0. Hostname. Stage run functional tests dev. When branch develop, branch main. Steps. Echo running functional tests on dev environment. sh/script/run functional tests http dev-app-url.com. Run post-deployment tests. Stage deploy to prod Kubernetes. Manual approval before deployment to production. When branch main. Steps. Input message. Approve deployment to production. Version nbuldnumber. OK. Deploy now. Echo deploying to production Kubernetes cluster. With kubeconfig credentials ID. Prod kubeconfig creds context name. kubrnetsbrodcu1txt. sh kubectl apply fk8/prod deployment YAML. sh kubectl set image deployment /noded zap equals $image name. End default. sh kubectl rollout status deployment /noded zap. End default. Post section for notifications and cleanup. Key takeaways from case study 2. Containerized agent Docker. Jenkins orchestrates the build within a Docker container, ensuring the build environment is consistent and isolated. Docker integration. Direct Docker commands are used within the pipeline to build, tag, login, and push images to a registry. Credential management. With credentials block securely injects Docker login credentials. Security scanning. Integration of a static container analysis tool, e.g., Trivy, ensures images are secure before deployment. Kubernetes integration. The with kube config step from the Jenkins Kubernetes plugin securely provides Kubernetes cluster access within the pipeline steps. Kubectl commands are used to apply manifest files, update deployment images, and monitor rollout status. Image versioning. The Docker image is tagged with the Jenkins build number, nbuldnumber, providing clear traceability from artifact to build. 11.3 Advanced deployment patterns. Beyond simple, copy files and restart deployments, Jenkins can orchestrate sophisticated deployment strategies for zero downtime releases and controlled rollouts. Blue-green deployments. Concept. Maintain 2 identical production environments. Blue, the current live version, and green, the new version. Jenkins orchestration. Build and test the new application version. Deploy the new version to the green environment, running full tests. Once the green environment is verified healthy, switch the network router load balancer to direct all incoming traffic to green. The blue environment is now idle and can be kept as a rollback target or used for future deployments. Benefit: zero downtime, instant rollback capability, just switch back to blue. Jenkins steps involved. Input for manual switch approval, SH, or cloud provider-specific steps for configuring load balancers, router rules, extensive health checks. Canary releases. Concept: gradually roll out a new version of an application to a small subset of users, the canary group, before making it available to everyone. Monitor key metrics, errors, performance for this group. Jenkins orchestration. Build and test the new version. Deploy the new version to a small percentage of your production server's pods. Monitor key metrics, e.g., using Prometheus and Grafana or other APM tools for a predefined bake time, based on monitoring data and possibly manual approval, either. Roll forward, deploy to the remaining server's pods if the canary performs well. Roll back, revert the small canary group if issues are detected. Benefit: reduces risk by exposing new features to a small audience first, allowing for quick detection and rollback of issues. Jenkins steps involved. Input for approval stages, SH, or cloud-specific steps for gradually updating deployments, e.g., Kubernetes rollout with percentage-based updates, sleep steps for bake time, integration with monitoring alerts. Rolling updates. Concept: gradually replace instances of the old application version with new ones, one by one or in small batches, ensuring continuous service availability. Jenkins orchestration. Build and test the new version. Deploy to a portion of the environment, e.g., 25% of servers. Run smoke tests, health checks on the updated instances. Repeat until all instances are updated. Benefit: simple to implement, less resource-intensive than blue-green, maintains service availability. Jenkins steps involved. Iterative deployment logic, health checks, usually via orchestration tools like Kubernetes, kubectl rollout, Ansible, or specific cloud provider APIs. 11.4 DevSecOps with Jenkins. Integrating security into your CI/CD pipeline, often called DevSecOps, means shifting security, finding and fixing vulnerabilities as early as possible. Jenkins is a prime orchestrator for this. Static application security testing, SAST. Concept: analyze source code for common vulnerabilities, e.g., SQL injection, cross-site scripting, before the application runs. Jenkins integration. Integrate SAST tools, e.g., Sonar Quebec with its security rules, checkmarks, Fortify as steps early in the pipeline, e.g., post-compile state. If high or critical vulnerabilities are found, the pipeline can fail, preventing insecure code from proceeding. Dynamic application security testing, DAST. Concept: test the running application for vulnerabilities by attacking it, e.g., fuzzing, penetration testing. Jenkins integration. After deploying to a test environment, dev/ca, trigger DAST tools, e.g., OWASP Zap, Nessus, against the deployed application. Report findings back to Jenkins. Dependency vulnerability scanning. Concept: scan your project's third-party dependencies for known vulnerabilities. Jenkins integration. Use tools like OWASP Dependency Check, Snike, or Trivy for container images as a pipeline step. They scan POM.XML, package.json, or Docker images layers and fail the build if vulnerable dependencies are detected. This is a crucial early warning system for supply chain attacks. 11.5 Data-driven CI/CD improvements, brief. Jenkins stores a wealth of data about your builds. Success failure rates, build durations, test results, and more. Analyzing this data can provide valuable insights for continuous improvement. Identify bottlenecks. Long-running stages indicate areas for optimization. Track trends. Monitor test pass rates, code coverage, or vulnerability counts over time. Prioritize fixes. Focus on flaky tests or frequently failing builds. Jenkins built-in reporting, like JUnit test results, and integration with external monitoring, Prometheus/Grafana, allow you to collect and visualize this data. Anecdote. Our team had a critical bug that made it to production. It was a stressful firefight. Afterward, we did a post-mortem. The issue was found in an obscure corner case that our unit and integration tests missed. We realized our existing test suite wasn't comprehensive enough. Inspired by a canary release talk, we decided to implement one for future deployments. We started with a small 2% traffic split to the new version, coupled with aggressive logging and monitoring. Lo and behold, the next asterisk critical bug was caught within hours by the Canary group before it ever impacted our main user base. The automated Canary deployment in Jenkins became our last line of defense, adding a crucial layer of safety missing before. Summary: this chapter brought Jenkins to life with real-world applications. We walked through conceptual pipelines for both traditional web application deployment and modern containerized microservices, highlighting Jenkins' flexibility in orchestrating diverse environments and technologies. We then explored advanced deployment patterns like blue-green, canary releases, and rolling updates, demonstrating how Jenkins enables safer, zero-downtime releases. Finally, we touched upon the integration of security, DevSecOps, into the pipeline and the value of data-driven insights for continuous improvement. By applying these patterns and understanding the capabilities outlined in this chapter, you can leverage Jenkins to build incredibly robust, efficient, and secure software delivery pipelines for almost any application. In the concluding chapter, we'll look at the evolving landscape of CI/CD and Jenkins' future. Chapter 12. The Future of CI/CD and Jenkins. Evolution and Emerging Trends. You've embarked on a comprehensive journey through Jenkins, from its fundamental concepts and installation to advanced pipeline construction, security, and real-world applications. But the world of software development, and CI/CD specifically, is ever-evolving. This final chapter will look at ongoing trends, how Jenkins adapts, and what the future might hold, emphasizing the importance of continuous learning and community involvement. 12.1 Jenkins X, Cloud-Native CI/CD. While this book focused on traditional Jenkins, it's important to be aware of Jenkins X. Jenkins X is not merely Jenkins 2.0 or an upgrade. It's a completely reimagined CI/CD solution specifically designed for cloud-native applications on Kubernetes. It abstracts away many complexities of building, deploying, and managing applications in a Kubernetes environment. Its goals, automated CI/CD, provides automated pipelines for Git-based applications, often leveraging Tekton, a cloud-native pipeline system. GitOps fully embraces GitOps principles, where all changes to infrastructure and applications are managed through Git pull requests. Preview environments automatically provisions temporary preview environments for every pull request, allowing developers and stakeholders to test changes in isolation before merging. Automated Canary deployments, built-in support for advanced deployment strategies. How it differs from traditional Jenkins. Traditional Jenkins, as discussed in this book, is highly flexible and can run anywhere, integrating with various deployment targets, VMS, bare metal containers. Jenkins X, in contrast, is opinionated and deeply integrated with Kubernetes. It leverages Kubernetes itself for dynamic agent provisioning, pipeline execution, via Tekton, and environment management. While traditional Jenkins gives you maximum control and flexibility, Jenkins X aims for higher automation and a more streamlined experience within a Kubernetes ecosystem. For teams building microservices on Kubernetes, Jenkins X offers a compelling, integrated CI/CD experience. 12.2 Cloud-Native CI/CD beyond Jenkins. The CI/CD landscape has diversified significantly, especially with the rise of cloud computing. It's helpful to understand where Jenkins stands in relation to other prominent tools. Built-in SCM CI/CD, GitHub Actions, GitLab CI/CD, Bitbucket pipelines. These tools are deeply integrated into their respective Git platforms. They offer tight coupling with SCM features, like protected branches, pull request status checks, and often provide easy, highly scalable cloud-hosted executors. Dedicated cloud-native CI/CD, Circle CI, Travis CI, Harness, Azure DevOps pipelines. These are often SaaS software as a service offerings, providing managed CI/CD infrastructure, simplified setup, and scalability without users needing to manage the underlying servers. Kubernetes native pipeline systems, Tecton, Argo CD. These are specifically built to run CI/CD pipelines directly on Kubernetes, leveraging its native capabilities for orchestration and resource management. Jenkins remains highly relevant, especially for organizations with a need for absolute control over their CI/CD infrastructure. Complex, legacy, or highly customized environments that require extensive integrations. Strong on-premise requirements due to security or regulatory compliance. Large existing investments in Jenkins knowledge and plugins. Its open-source nature, plugin ecosystem, and deep configurability ensure its continued adoption and evolution. 12.3 Emerging Trends in CI/CD. The field of CI/CD is dynamic, with new methodologies and technologies constantly emerging. Low-code, no-code CI/CD platforms aim to simplify pipeline creation further. While pipeline as code, like Jenkins file, is powerful, it still requires technical expertise. Low-code, no-code platforms offer visual editors or highly abstracted configurations, making CI/CD accessible to a broader audience. This often comes at the cost of less flexibility for highly customized workflows. AI/ML in CI/CD, AI Ops for DevOps, artificial intelligence and machine learning are increasingly being applied to optimize CI/CD. This AI Ops movement aims to predict failures, identify patterns that lead to build failures before they occur. Optimize test selection. Intelligently select a subset of tests to run based on code changes, speeding up feedback loops. Root cause analysis. Automate the identification of the root cause of build or deployment failures. Smart automation. Suggest optimal pipeline configurations or deployment strategies. Shift-left security. As discussed in Chapter 11, integrating security automation earlier and more deeply into the CI/CD pipeline is a growing trend. This includes advanced static code analysis, dynamic application security testing, software supply chain security e.g., verifying component integrity, and secret management. Jenkins, with its rich plugin ecosystem for security tools, is well-positioned to orchestrate these checks. Inner source. Applying open-source best practices, like transparent development, contribution guidelines, public roadmaps, within an organization. This fosters collaboration and reuse of CI/CD pipeline code, potentially leading to more shared libraries and common patterns in large enterprises. 12.4 The continuing evolution of Jenkins core. Despite the rise of new tools, the Jenkins project itself is far from stagnant. It continues to evolve and improve performance and scalability. Ongoing efforts focus on optimizing Jenkins core performance, especially for the master, and enhancing its ability to scale horizontally. User experience. Improvements to the UI beyond Blue Ocean, which is now a maintenance-only project, better default configurations, and simplified setup processes are continuous goals. Cloud-native adoption. While Jenkins X is a distinct project, the core Jenkins aims to improve its integration with cloud services, containerization, and Kubernetes, e.g., through robust plugins to make it easier for users to build cloud-native pipelines. Security focus. Security remains a top priority with regular updates, vulnerability disclosures, and continued hardening of the platform. Community contributions. The strength of Jenkins lies in its global community. New plugins, feature enhancements, and bug fixes are continuously contributed, ensuring Jenkins adapts to new technologies and user needs. 12.5 Continuous learning and community involvement. The world of CI/CD and DevOps is fast-paced. What's cutting edge today might be standard practice tomorrow, and new tools emerge constantly. To stay effective, continuous learning is essential. Official Jenkins documentation. The Jenkins website, www.jenkins.io, is your primary resource for official documentation, plugin lists, and release notes. Jenkins JIRA. Follow the Jenkins project's issue tracker, JIRA, to see what's being developed, discuss features, or report bugs. Community forums and mailing lists. Engage with the vast Jenkins community through official forums, mailing lists, or online communities like Stack Overflow. Online courses and tutorials. Supplement your learning with structured courses on platforms like Udemy, Coursera, or specialized DevOps academies. Industry blogs and conferences. Stay updated on new trends and best practices by following leading DevOps blogs and attending industry conferences, virtual or in person. Experimentation. The best way to learn is by doing. Set up new Jenkins instances, experiment with new plugins, and try out different pipeline patterns. Consider contributing back to the Jenkins project. Whether it's through code contributions, improving documentation, helping on forums, or simply filing bug reports, your involvement strengthens the entire community. 12.6 Final thoughts. Your journey with Jenkins. You've now completed your journey through Jenkins Demystified. From understanding the foundational principles of CI/CD to mastering Jenkins installation, job creation, pipeline coding, security, scaling, and operational maintenance, you are well equipped to automate your software delivery processes. Jenkins, despite its age and tech years, continues to be a powerful, flexible, and highly relevant tool. Its strength lies in its open-source nature, vast plugin ecosystem, and the passionate global community behind it. It offers an unparalleled level of control and customization, making it suitable for a wide range of organizations, from small startups to large enterprises with complex, diverse, and often legacy-rich environments. The true testament to a well-implemented CI/CD pipeline orchestrated by Jenkins isn't just faster releases. It's about higher quality software, catching bugs earlier, ensuring consistent builds, reduced risk, making deployments routine and less stressful, faster feedback loops, empowering developers with immediate insight into their code, improved team collaboration, breaking down silos between development, testing, and operations, increased innovation, freeing up engineers to focus on creation rather than manual toil. Embrace the principles of automation, continuous improvement, and the DevOps culture. Let Jenkins be your trusted partner in building robust, high-quality software and delivering value continuously. Good luck on your ongoing automation journey. Further reading resources, official Jenkins website, www.jenkins.io, documentation, download, blog, community, Jenkins plugin index, plugins.jenkins.io, Jenkins JIRA, issues.jenkins.io, pipeline syntax reference, accessible from your Jenkins instance, typically at Jenkins URL pipeline syntax, Jenkins code on GitHub, github.com/Jenkins. Continuous Delivery book by Jez Humble and David Farley, a foundational text on the principles of CD. The DevOps Handbook book by Gene Kim, Jez Humble, Patrick Debois, John Willis, explores the principles and practices of DevOps.